I think you're only going to be here if you just saw the announcement on Discord saying the event had started. So I'm just going to quickly give you the fly through of where we're at, and then I'll take 5 minutes to announce on every other platform that we've started streaming. So since this will be cut for YouTube, first 5 minutes are important. Let's jump right into it. The objective for the OSSM on stream has been to build a live pattern drawing tool. So on the dashboard, you should be able to create a curve, and this curve is then saved on the dashboard and on device so that you can have custom patterns generated from a spline, no matter where you are. There are a few tricks in this setup, a lot of math, and a couple of problems remain, but we're working through them. The current state is best summarized here by these graphs. Beautiful little history here of us correcting some issues. What we see on these graphs in general are four charts each. The first three are critical, the last one is not. This is our calculation of time. Should be simple, but because we are doing time between 0 and 1, we want to make sure that we're scaling inside of that range. Clearly, there was something going on incorrectly in the beginning. This was impacting the position, impacting velocity. These calculations were all dependent on each other. So we cleaned up our time computation. We made sure that we could generate our sinusoid. It's looking very good here. These are just functional outputs, not motor position. That is still choppy. We found an issue with our velocity computation. We did a little bit more math, got into a little bit more cleanup. We're still seeing velocity issues, and boom, we're getting real close. This is the history. Time is now, in this case, not between 0 and 1. This should be in, I believe, seconds. Would this be in seconds? We'll have to confirm that. It's not clearly noted on the graph. But we're seeing the shapes. Things are looking good. There was a threshold, a minimum on velocity. This was put in place because the stepper does need a failsafe on the lower end of velocity. However, this was way too high and was impacting the chart. So we played around a little bit more, got things closer and closer, tried to work better on our first and last index problem, where the first and last points of our patterns must be identical. We made a couple math mistakes here, so kept going, kept improving, just trying to get a beautiful sinusoid, and here we go. We're in beautiful sinusoid land with a beautiful velocity as well. So this is the derivative of a sine, is a cosine. It is, it's hard to see, but I would believe this is approximately a cosine. You have to account for the fact that this is not actually velocity, it is speed. So there is no negative present in this calculation. We could include it, but it is just not here today. And here we go. We also have our sawtooth pattern, which is generated here also from just a spline. These two test patterns and the code that I'm working with is available in the OSSM repo. So that is Kinky Makers, a GitHub. Awesome. Sorry, the branch is called, oh, right, Kinky Makers GitHub. The project is Awesome Hardware, and the branch is AJ/awesome-patterns. It is not safe for play, but it is safe for critical feedback. We have not done the polish yet, so there is some annoying code, definitely some ugly patterns, some doubly nested well statements, for instance, that I find particularly toxic. We'll pull those out eventually. All right, it's enough for an intro. We're now going to take 5. I'm going to make sure I do the email blast everywhere so folks know they can tune in. And we're going to hang out on this graph or this picture of Nickelback. All right, stick tight with me. Here we go. Ba, ba, ba. Look at this graph. Take a peek. Jumping across. Gotta open all of the things. All right, first things first, let's get our little pop-out chat so I can see who's saying what. Lovely. Let's see if anyone caught the notification in either place. Not yet, but I did schedule this, so I want to make sure I'm on time. Even if I had to rush a little to start it, that's okay. And we'll go into our cross-platform announcements app. Post IZ. Shout out to them. Definitely loving their product. So just gonna give them a good old representation. This thing is awesome. We're not using the OpenClaw integration, probably won't, but I will say, loving the open source scheduling of our social media posts. Let's see. When is this one scheduled for? Interesting. Interesting. Maybe I'm confused. I think I see a time zone issue. Or just a refresh issue. Easy to resolve. Okay, there we go. Let's create a post in all the right places. Boom, 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 boom. We will grab this picture of not Nicolas Cage, Nickelback doing, look at this graph. This way. And we're gonna take a little photo here. Hang out with me. Save to downloads. Let's see. Can I go here? Will that work? Capture. Photo taken. Okay, this is gonna be our post photo. Okay, we are live on Twitch TV/Research and Desire. Live coding. The awesome pattern drawing. All right, let's go. Let's go. Nearly there, folks. R&D Discord internal. Let's go marketing chat. Let's go R&D Discord. Let's go announcements. Let's go into the KM Discord and go awesome announcements. Gotta find it, gotta find it. Instagram, LinkedIn, subreddit, awesome, underscore machine slash. Perfect. We will do a link. Okay, announce. There we are. We're gonna post now. 3, 2, 1. No short links because they mess up. Okay, let's just check in on chat. Stream Elements is present. Awesome, folks. We are launched and live. Let's do it. Okay, what other setup do we need to do here? Anything critical? Well, before anyone specifically joins, maybe we'll do the fluid collection. Just want to make sure that I have access to waters and all the other good things in mind. Oh, wow. 3. There we go. And then we have a bit of a project running in the background, which we can double check on before we totally lose focus. Let's give it one moment here just to confirm what's working and what is not. All right. Production build, I believe, worked. Confirmed. Just a quick parallel issue to make sure that I'm putting out fires as they arise. The only thing we have to do then before we totally remove attention from this little fire is reset the config. Unfortunately, you won't know what I'm working on. Fun secret. You'll see soon. I promise. Okay, let's go into this project, make sure we enter settings and reset the thing that we had just done, which is just gently secret. Root directory. Perf. All right, done. We're good to go. Let's set this. Good. Also set. Hey, yo. Love to see it. Do an attempt here. All right, let's finish up our little issue if required. I don't think it is required, therefore we won't. Let's pick up some context. First things first, just understand where we left off. I'm going to switch back over to the awesome branch. Just make sure I'm in the right place. So clear branch. Git branch. Where are we? Yeah, wonderful. We're on the correct branch. We should have our awesome on the correct code. We'll have to get some things plugged in here to make everything work, but things are looking good. I'm going to put this on it in frame. Oh, you can't see cursor. My mistake. Interesting. Let's try to bring her back. You can see Chrome. You can see freeform. But clicking on cursor, you get nothing. Let's try one more time. We're just going to clear this. Go back and try to reload cursor. Hello, there she is. Welcome, welcome. All right, awesome. Okay, lovely. So this feature is extremely close. The objective is MVP. This MVP has become medium in size and scope, but it is still tractable. And it feels like we're getting relatively close to the finish line. Less polish. The polish is going to be the step takes the most effort. Let's just get some things to plug our awesome into power. We'll temporarily use it for our light, because it's so light. It's a hungry guy. See, click this bad boy in. And generally just make sure you can see what's going on with the OSSM. Oh yeah. Okay, loving it. Let's take a look here. How is frame? Frame says you cannot see. Awesome. Uh-huh. Changed around my configuration just a little bit, but I'll tell you what, the way I had it before was better. Uh-huh. No, the camera's just too high. Just too high. But what can I do? Easiest thing to do is put some books underneath this. So that's the plan. Let's find out how many books AJ has. Okay, okay. I have a different idea. It's my tiny little dresser. I'm gonna use it as a desk instead. That means this guy gets to come over here. Oh yeah. Hey, not bad. Half desk. And plus it's the thing that has actually all of my R&D tech stuff in it. So perfect. Coincidentally, exactly what I meant to do from the beginning. Also, side benefit, maybe I can put the light in frame and you won't even see it. No, you do see it, but that's okay. We'll keep it over here. Thanks for setting up with me, folks. Appreciate it. All right, let's see what we got in chat right now. Cool. Ciao. People will slowly roll in, I'm sure. C'est la vie. And we're just going to do then all of our setup and prep and roll right into it. Got that update at the start. And then anyone else who's watching on YouTube, I hope you skip to the part where we start making stuff, because we're nearly there. Okay, is there anything critical that I need to tie up before we do this? One moment, let's clear this. Just hiding cursor again to make sure that any previous chats that are potentially not that risky, but just like early info are dealt with. Okay, awesome. I think we're good to go, folks. Yeah, there's a bit of work I'm doing in parallel, but I'm going to put that down and we're ready to catch up. So let's check in and see where we're at with this pattern drawing system. We're focusing in on pattern replay. We've noted a few errors or issues. One that I do not believe we've addressed yet is simply ensuring that during a speed change, our calculated positions are smooth. So what we're going to do is we're going to work in context here. Let me make sure this is clear for anyone just joining for the first time. It is this issue. So if you have a sinusoidal function and you change the frequency, but evaluate it at the same time, then you will jump. Your expected position or like target position for the stepper will rapidly change as you're scrolling through your speeds. That's our change in frequency. This is not acceptable. It does lead to bad sex. So we have to go change it. What we have to do is simply compute the function or an offset on the functions that we evaluate here the moment you change, instantaneously guaranteeing that the functions are evaluated at the same state. I will check to see how far we made it on this, but we did compute the solution. The solution was computed here. Right. So this is, I have to confirm our work. Let's just work through it again, make sure we're clear. So we stated that if you have a function g, which is a function of x, which is your time or your horizontal axis, plus an offset divided by some scaling unit, and it is equal in a moment in time at a specific x to that same function evaluated at that same x, but with potentially a different offset and potentially a different scale, then on the assumption that there is an inverse of that function, we can solve for dx1, the current offset. Now we know that at speed 0, or we can make the statement that at speed 0, our dx is 0 and our scalar 0 is 1. The reason we can make these assumptions is because g can contain anything, can act on our function in any way, and so these are in our control. If we set these things to be true, then we can solve for x1, so our offset, as follows. x1 is equal to your scalar s1 minus 1 times x. Cool. Now we work through here, we have our general case, and now the trick, the question falls to us, how do we compute Sn? We recall that we do have a upper limit on Sn, which should, where Sn is the maximum. So Sn should be computable because there is a maximum speed that the OSSM can move. Since there's a maximum speed, this is something we can work back from. So the statement then is if, well, we don't have to write down the math, but essentially it's stating we can determine our scalar. Let's check here. All right, we got no one in chat at the moment, which is perfectly acceptable. Let's go make sure that our Discord announcement did work in all the right places. We're going to check in KM. Good stuff. All right, happy. We're going to make sure that in, yep, good as well. Our awesome live coding session is live. We'll check quickly on all of our other platforms to ensure that we're posting appropriately in Reddit, in everywhere else. Let's go take a peep at our Reddit. The current Reddit we're using is awesome_machine, which I am very aware is an unnecessary use of awesome. It's like open source sex machine. Love it. Hilarious. But granted, we still have people there, so let's go make sure they're with us. Now we'll make sure that Instagram is working. Just cross-platform, quick vibe check, chill. Look at our home. I'm a little off screen at the moment. Hey, yo. Yeah, look at this graph. Okay, I'm gonna have to definitely polish this. At the moment, it's not doing a good job of cropping just to my face. Hey, it tries, but can't have everything, right? Hey, yo. But looks like everything is as it should be. All is right in the world. Yep, look at this graph. It's alive. Done, folks. Done and dusted. Yeah, let's just jump in. Let people join chat as they go. For now, it's you and me, baby. Okay. Coming through, coming through. We're here. We'll clear this guy. Let's hang out. So this awesome still needs a motor plug. We'll have to provide it. Let's make that happen. In fact, what we were doing prior is, in order to generate these graphs, we were using pure code, just code, like unit tests. Let's go back to this and let's ensure that we have that set up. So we, inside of the unit tests, generate the code and then have a Python script that runs against it to generate the plots. Let's open that. So inside of, I'm just going to open this more convenient version. So inside of Spline Patterns, let's take a peep. We import our patterns, we draw them, and we compute. Where are we at? Where is our main? Yeah, okay. We're sweeping through with a fake clock. Love it. Per pattern. Generating out this. Of LG. So the thing that we want to check now, and this is a moment where we're going to vibe code, is we want to change the test to generate data at 2 different speeds. So we want the speed to change significantly between 0 and the end. I think the way that I want to do this is that in a new test, so in a new test, we like to test speed changes and plot them. So that would look like, let's make a choice. After looping through each test, test pattern, drawing them, also generate data for, let's not write a prompt yet. I don't want to do a speed change from, what's interesting here? I think I would like to see 3 cycles for each of the following speeds. So I want to see essentially 3 full cycles of the pattern at each of these speeds. So that'd be 0, 10, 20, like percent, 20%, dot, 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 90%, 100%. Are these all required? No. No, they're not. So let's drop this down to just 3 critical ones. For a total of 9 patterns shown on the same plot. Let's go. Hey, talk to this boy. We're going to say basically this. Please make an additional set of sweep tests, which, in addition to sweeping through time, will also have the following speed changes. and run through either A, 3 cycles, 3 cycles, or maybe you need a fourth one here. Let's say 10%. Wait 10 seconds, i.e. for the case of 0% speed. Maybe 0% speed should be its own thing. Let's go ahead and do that. Yep. The speeds we want to check are 10% speed, 50% speed, and 100% speed. Now, in code, I believe we don't need to change anything. This is just for tests. Before I confirm that's the case, when I go look at our spline pattern definition for evaluate, I believe that I had modified it to take in speed percent right here. Good. And we're doing a bit of an early computation, time since millisecond start, to get the values we need. So it should be fine. Don't change source code yet. Just the test code. Make sure we'll be able to generate plots. All right, there was a analysis tool we created here under analysis for generating these plots. PNG plot spline, baby. TY. Okay. Now, there's so many things that are still left to do. And we're going to let that guy run in the background here. Once we figure out the speed offset and make sure that it's smooth and gracefully transitions between these speeds, we'll even perhaps have a test that generates a plot for slow ramping so that we can see what that looks like. We will then need to put this on device where we have a jitter issue. What I mean by that is as you change speed, not even as you change speed, at a static speed, going through a sinusoidal pattern. So like this guy, a super easy one. Somewhere in this range, we have a position issue. So somewhere here, we just see the motor just stuttering like that. We'll have to figure out why. It could be our calculation after we do evaluate, which is getting sent to the stepper. There is a little bit of remaining calculation from the first pass vibe code which we used as scaffolding. I think we should delete all that and just rewrite it using our meat brain. That'll be the best approach. Once that's clear, we could write a few more test patterns and have a bit of fun with it. And then we should set up the Bluetooth to send, receive, and manage patterns. Oh, hey, Eagle. Welcome again. Good to see you. I'm glad you're here. I think it is right now. Let's check to see if it's you and me. I think it's just you and me. I can't check users at the moment. But we'll let people fly in as they can. This one was rescheduled from Saturday. I think I'm going to generally reschedule this one off of Saturdays onto Sundays. They're just more flexible. But because of the reschedule, we might have a slower start for the audience. But we'll see what happens. More stream is more stream. Okay. Okay, so let's take a peep. All right, we got these running. Okay. Uh-huh. I think there's miscommunication here, buddy. So this is supposed to be a sweep at a different speed, and I said 3 cycles. So I think it did not realize what I meant. When don't you see in the plots since the wall clock period is fixed at total duration regardless of speed. Okay, we got to figure it out. So at 10%, only, well, we'll go fix our time calculation. That's the reason why we set this up. The thing I'm most interested in is making sure that we're combining these into one chart. Okay. Don't worry about source code. But to be clear, I want all 9 cycles in one graph using the same clock. In fact, we want something slightly different. We do want the moment that we change speed to not be at 0 or 100%. So we should say, but we want one graph, want one graph for all plots. And I want the speed to change. I just want one cycle. Yeah, let's be more specific. 75% of a cycle per speed. To be very clear, not total duration. How would we compute this? So we would want something to the effect of, because total duration is the computation of the length the pattern will take at maximum speed. To be very clear, I want to use the same clock and simulate a speed change during operation, and where the time point is not in fact, we should even just let the damn thing only have 2 speeds, 10% and 50%. Just jumping instantly to that is going to have clarity for us. Is not at the start or end of the cycle. To facilitate this, just have exactly one speed change from 10% to 50%. Again, same clock. Let's go. Let's see what happens. How's your day going, Eagle? What are you up to today? Hope you got something fun in the works, or at the very least that you get yourself a nice coffee. You're making my day by being here, so certainly appreciated. Definitely. Just woke up. Awesome. Yeah, get a coffee on me. If I could send you, I guess it's like $10 now for a coffee in general in the world, but if I could, I would. And if you're ever in Canada or right now Thailand, let me know. Coffee's on me. Okay, so the problem is that this fella does not understand. I don't drink coffee. Oh no. What's your go-to? Here they do Thai tea. That's the thing that people like, but it's a bit sweet for me. You got to get it at like 25% sugar to make it a daily drink. Okay. I don't want you to modify any source code here, fella, so. Let's see what happens. Okay. I'm okay if it just switches at a random time, because all I do need to see is the step jump. I don't believe that it's going to succeed at actually computing 75% at 10% speed, because it is not scaling correctly. We have to remember total duration is the duration if your speed is at 100%, computed by the maximum slope between 2 points. And even that calculation is not quite right yet. We have to repair our slope, max slope calculation quite a bit. So not trusting it, not believing in it just yet, but I can be an optimist. We'll see. We'll see what happens. So I want to check the command it's using here to gen and then plot. Is it doing it automatically, like kicking off the plot PIO test? Yep, function. The question is, does it then pipe into the Python function? No, it just runs the Python function separately. Okay, cool. We'll start doing that ourselves. Chill. Speed change. Let's minimize you. I got to see what's going on over here. Yes. Yes, this is what I want to see. Okay. Right, so it's doing it per pattern, showing us what the change looks like per pattern. This is exactly what we're seeing on device. Awesome. All right, this is going to allow us to change, work on our offset. Now, we are going to need our previous offset, I believe. Okay, let's do a little thinking. So let's pull these graphs in. This elucidates the problem perfectly. We have a rough solution. We need to find the exact solution. Ba-ba-bum, ba-ba-bum. All right. So our solution that we found is here. Nope, not that one. So given that our function can be defined like this, we have determined that the solution for our horizontal offset, and we must find now the scalar or the scaling factor, is as follows, where dxn is equal to this. We've determined that dx0 is equal to 0 and s0 is equal to 1. We must determine Sn is equal to unknown. And we'll see. I have a physics degree. So my degree was in mathematical physics. And for a little while, I was thinking that I would either do experimental semiconductor, superconductor physics, or briefly, I was interested in theoretical physics. I did then immediately start a software company instead, and eventually, over the years, bumped into research and desire, where Alex, the CEO and founder of Research and Desire, and I just meshed, got along well. And now Lucy Shapar from the Kinky Makers community and her previous projects has also joined the fray. She's awesome. We love having her on team. I think all three of us have. I know that Alex has a technical degree. I believe it's engineering physics, or what's it called? Yeah, I think it's engineering physics. That's the name, right? It must be. Lucy, I'm not sure about her degree, but her technical background is, yeah, enormous. She knows what she's doing, that's for sure. How about yourself? Are you also an engineer? I don't know if I count as one. but we'll pretend, just you and I. Yeah. Alex started Research and Desire as well as Kinky Makers. So Alex started it, specifically started Kinky Makers with James just before COVID. It was a physical location inside of Toronto, Canada. And uh, it used to be just a makerspace where you could freely make sex toys and other sex tech. I believe the story goes that during COVID, it became difficult to have a physical location, maintain the rent, etc. But at that same time, yeah, Alex had started Research and Desire to sell one of his products, the Deep Throat Trainer, uh, and facilitate the sales of parts for the open source sex machine, which he also started uh, with James and the Kinky Makers. Commuter technician, awesome, cool job, cool job. Maybe that makes sense why you're with me here as often as you are. You can just throw me in the background while doing things. Again, totally appreciate it. So you're a hero, Eagle. Excuse me. All right. SN. This is our trick. If we figure this out, we're golden. So what do we need to know? Well, we do know our total duration. Yeah, maybe we can do this again. Like a heuristic perhaps is better than a formula. At 50%. Is a heuristic going to be able to solve this? I don't think so. Oh, Gore. Hey, honestly, it didn't recognize till right now. Yeah, great to have you. I didn't realize because Eagle Deluxe is not the name Gore. Yeah, perfect. Yeah, connected. Thank you. Hmm. Okay, just thinking through this. The boundary value must be the same. The issue, though, is that there is an offset for 10, and we already don't know it. So we have to be, yeah, we have to be a little bit clever. We do have an offset for everything, right? And are they going to impact each other? I think we know that if you're starting at offset 0 and then going to offset 10, it's easy. Because this is in the assumption that there's a jump from a discontinuous jump immediately from 0 to 10. Okay, so we might have this formula might not be valid unless we're jumping directly from 0 to a number. So let's still solve it. And let's think about the case where we're jumping from 0 to 100. We're going to propose the case. In the case that we're jumping from 0 to 100% speed, we will state that this is true, that this is our formula. We are able to compute our max speed. We do know that we have computed total duration. Let's write our variables here, make sure we are aligned here. Total duration is equal to the speed. Yeah, how do I describe this on cam? Is essentially set such that our pattern is physically achievable. This is what I'm about to state is not exactly the correct math as we've implemented it, but it is the correct desire state. So I'll have to fix this to make sure that it is true. So it's as if we say if our pattern is g of x, then max speed is equal to max g prime of x. Essentially, we're saying the maximum speed the maximum possible velocity inside of our function has to be scaled so that it is our max speed. Or for any pattern, the maximum speed on the pattern must equal our maximum speed in code. Okay. This is just a variable that we have. We're not going to work with the derivative in the sense that we're not going to like add that into our solution and kind of like reverse engineer it. I think what we're going to do instead, I'm just going to do a user's check here. Good stuff, is we're going to maximum speed. Just see if we can figure out what SN then must be. Let's do this. Let's do a simple heuristic. Because I am going to drive myself crazy. Yes. So in the case of the sine wave, let's go there. Yeah, jumping from 0 to 100 is not ideal. But let's go ahead. Let's go ahead and say just gotta get my head on my shoulders here a little bit. That's all. If our pattern is a sine wave and our speed is 0, we will have a line. That is the case. So this is the infinite divided by 0. Is this correct? So this is essentially sine of x divided by 0. Yeah. Not really. It's like if you evaluate this, you're not going to receive this. I'm curious now what Wolfram alpha is going to draw for that, but it should be any arbitrary value. It's just like frozen inside of our product. Alpha, thank you. Ba-boom. Just want to see what Wolfram alpha does draw for sine of x divided by 0. Yeah, of course. It's undefined, so it's literally whatever value we want. If we divide by 0.5, by the way, we have a high frequency function. If we were to just make sure that we're getting this right, we're planning to divide by infinity instead. Let's make sure that I'm not crazy. Want to get our scalar correct. Right, yes. Divide by 10, so it's divide by... Okay, so if we were to then multiply by our speed value, is this more appropriate? Yes, this is more appropriate. So that if we're multiplying by 0, okay, we get this, just a horizontal line. It is 0. That is for time 0, though, so we do need the offset, which means that if we assume there is, what would be appropriate here? Okay, so it's going to be times our speed. Scalar for now. Sorry. Scalar, it's a percent between 0 and 1. That's what I mean to say. This is going to be just for s equals very, very small. But non-zero. We'll assume that's the case. And then we need to switch into, we're going to assume that s jumps to 1. Just lost it. Where did we go? And here we will have our dx. Now for any x, we must have, we're going to call this S0, and we're going to call this S1. Now we must solve for dx 1. We will include all this. This is the same thing as before, but now I'm just working through it again to make sure I'm not a crazy person. This will essentially just be a sine wave. We'll grab our silly little drawing of, in this case, an inverted sine wave, just for the purposes of talking through this and trying to not be crazy. Here we are. Poorly drawn sine wave at the ready. Okay, so if thinking through. Mm-hmm. Let's choose a constant value. Let's say that our position is set to, because what I want to do is solve without doing the sign. This could essentially, for very small, be kept at any static value. We're going to make the statement that it is still a sine. How can I do this easiest? But it is time frozen at hey 1. We're going to assume, what am I thinking about here? Why is this not seeming like it's going to solve out to me or get me further along this path? Yeah, let's not chase it. Let's just plot it using whole numbers. So we're going to set the frequency to be 2 pi. We should set this between 0 and 1. Incorrect. But sufficient. That'll do. Let's go into 10 here, and then 20. Chill. Works for me. And then let's also consider this other one. We're now talking about a change. Let's try to imagine the change occurring at 10. So 10 on this scale. We're going to say this one is twice. And we're just going to compute the offset such that these are aligned and make sure that I'm not crazy. Because I'm definitely overthinking this, right? Like, it must be the case. And once I just see the solution, it'll fall into place. So in this case, the sine wave must shift to the right. To the right should be a positive shift. Let's confirm that is incorrect. It is a negative shift. Love revisiting trig live on call. How embarrassing. Wonderful. And in this case, we do want to just shift by 10. Not correct. What do we want to shift to the right by? I don't think. Right, because it's times 2, so times 5. So essentially we want to shift to the right. So dx2 in this case is equal to the negative. So at a point in time, we're going to call this dxt. Wish I had a better name in system here. It's called z. Z is our like point in time snapshot when we're changing. Then dxt is equal to the point in time that we're changing so z over S1. which essentially, I'm just confirming here, because ignoring the 2 pi for a second, we could just extract that out. The only thing that's variable is the scaling factor on the left, which implies that it is just not relevant. So we're just subtracting the point in time value from the horizontal. I think that's the case. I think our, yeah, excuse me. I think it is the case that we're just subtracting in x, the point in time that we're evaluating at, from the end. I don't think it's as complicated as we were making it out to be this whole time. Let's confirm this is the case. So if I were to go into the code, boom, 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 and we're not going to worry about the implementation just yet of the stepper stuff or the stroke pattern stuff. We're just going to look at our evaluation for patterns. Okay, given a speed percent, we want to compute our time. And when time changes, we want to subtract in x the previous offset. So, okay. So our time here, first let's figure out if this is working in a way that we like. It is just multiplying by speed percent times total duration. If speed percent changes, this is when we'd want to add our subtraction. The subtraction then should be permanent or semi-permanent. So let's, for testing purposes only, declare a static. This might not work inside of our tests. Let's say static int offset is equal to 0. Static double, just for testing. This is a terrible way to set up this code. Very messy. To inline define it. That's insane. Last speed is equal to 0. And we're going to say if last speed is not equal, last speed equals speed percent, and time offset. Let's do it even before computing this. That's a time offset. No, I think this is going to work for 1. Hey there. Our chat is so strange. Instantly, we get another one. I'm so surprised every time. But usually within the first 15 to 20 minutes, we get a spam message. This user has been banned. See you later. Gotta find an auto mod for this. Okay, it's very tempting to have the time offset be this. So the milliseconds like right now, minus the start time. Would this be appropriate? It's a good question. Because really what I want to do is do our fmod here. Because this is milliseconds since start time. Yeah, time since it started. Minus our offset. But really what I need to know is where are we right now in the execution of this pattern? What's the percent that we're through the pattern? Because I just need our last evaluated x, or essentially our current x value. which is this. Okay, just thinking about it, the problem is that we have potentially another offset here, which we're going to ignore. The z value is our point in time where we are restarting from. I do not believe that it is what I've written down here on screen. I do not think this is the case. I'm going to prove that to myself. I'm just going to, if it is anything, it would be proportional to this. I do not think it is the case that it is this. So we are going to fmod and subtract time offset. And look, it's it, folks. Now, this is speed percent, as if we're starting from scratch again. I wonder then if the computation is more relevant to the speed percent. Now, we noted that if there is a scaling factor, that it should not be present in this calculation. So it does suggest that time offset should be out here, divided by total duration without a speed percent, or perhaps times last speed. Okay, let's attempt. We're gonna make our effort. So minus last speed times speed offset over total duration. Don't think it's it. We're gonna try. Well, we just need a different thing to think about. So we're going to regenerate those graphs. CD software. Excuse the mess. Let's clean this up. Okay, so we'll regenerate our patterns into the analytics directory, one level up. And then we have to rerun our plot. Let's go find our plot code. Yes, thank you. And thank you. No such file or directory. Let's go. Okay, we got our plots up. Let's take a peep. This did not seem to have a measurable impact. Is that accurate? Did it do truly nothing? Let's compare. If it had truly no impact, oh, no, now we're undershooting on one of these graphs and the velocity, but we are closer. It's not our time calculation. Our time calculation is, it seems, still off. Where is time getting returned and then printed? Ooh. Where are we printing time? What a question. All right, so I'm going to compare. Let's pull this over. I'm going to let you see as well. Let's look at the same chart. Copy. Now, we need to find out where this is getting computed because it does seem deeply inaccurate. Spline T. You should also note we are seeing a closer approach towards continuity. Velocity does not seem to be continuous. We should ask the question as well if we desire. No, I don't think we desire velocity to be continuous. And in fact, if we get the computation right, it should become continuous. I think that's the case. Now, the issue is we are now undershooting. We're doing much better on position, but certainly undershooting by quite a bit. In fact, it dropped back down to 0 because we're fully subtracting off, which is what is expected. Okay, so good. Okay, we see what's going on. We are subtracting too much. Because it is now subtracting off the entire thing. Time sense. We don't. So we want to subtract off, like, if we're at, what's our timestamp here? Whatever this is. This timestamp is approximately, who knows, 10% of the entire function. So at this point, we want to make sure that we're subtracting off that value. We are getting that value here and multiplying by last speed. But we're multiplying it after redefining it. So perhaps this is the critical difference, meaning that we just need to compute this, which would be, if these two values are identical, let's assume for the time being they are, minus last speed. Let's take a look. This is going to work for positive values, but I think not negative steps. We're going to have to just be cautious. Potentially it'll work. Oh, no, I think it will fail for negative steps because it's going to then be negative time. We'll be careful. We got to go take a look at that. But let's try this in the case that last speed is not equal to. And here we go. We have to update last speed later. CD software. All right, I'll open 2 of them. It's a little messy on such a small real estate to have 2 of these little terminals open, but it's acceptable. I could open a different one. Let's take advantage of the radar one. Okay, so clear, CD, CD awesome, CD software, clear, and actually let's have this one be analysis. CD, boom, boom, CD awesome analysis. Okay, and then let's go into CD into software. Good stuff. Now when I run our test command, it will generate 0 test cases. Not what I wanted to see. Huh. Uh-huh. Yeah. CD software. Make sure I'm spelling everything right. That seems, oh, right, because it's misspelled. Okay, great. Perfect. Always the case. The simple stuff. Retest pass. Great. Let's pop into analysis. We will copy out our analysis Python code. And into, here, analysis. Let's take a look at these plots. That's crazy. And not right. Yikes, dude. Yikes. Okay. Not right. Because last speed was, starts at 0. So the subtraction here is definitely wrong. Well, would it be? What is occurring? Position jumps up rapidly. Our calculation is definitely wrong. Definitely wrong. Last speed is not updated until later. This could be poor variable definition. It could be a lot of stuff. Okay. Speed percent. So this should be 10 minus 0. That does not seem to be the case. If right, I think we do still need to have a static value for time offset. Okay. So let's also check this. Last speed is not equal to speed percent, but we do need our time offset, I think, because it's at a point in time that we need to subtract. So let's try one more attempt. And the issue prior was last speed is getting calculated too early. Time offset is too late. So we'll have to just, again, test code, make it a little bit nasty. We're going to update last speed late. In fact, we can say always last speed is equal to speed percent after the calculation runs. And time offset only changes when these are unequal. Okay, let's confirm. All right, round one. Bye. Test patterns. Thank you. Okay, and then analysis. Let's go. Bum, bum. Yeah, so interesting how wrong this is, and in the ways that it's wrong. All right, instantaneous spike and then failure. Last speed is equal to speed percent. When last speed is not equal, we save it. There is a chance that it's just simply failing to define. And let's confirm here. This would force it to, if these are equal, in fact, we can make our life a little easier if we believe this is even at all the correct step. I don't think it is anymore. I think we are close, but missing something. Let's move our definitions. We're not confident enough, I think, to move it to class level, but I will declare it as static again, just to see what happens. Just a little higher. Now what I'm expecting is that t is equal to speed percent. Yeah, okay. So last speed divided by total duration, so it's a percent of your offset in time. This is not right. This is not correct. Let's just prove it to ourselves that it's not correct, and then go do the correct thing. And then maybe what I got to do is grab a piece of paper, a classic piece of paper. Because something's so simple occurring that's just like messing with my brain today. Okay. for some reason, spikes up and then fails. This is still incorrect, obviously. But we are then resetting here back down to 0, which is not desirable. Let's do something dumb. Let's just go dumb for a second. Let's just like, where's that at? That's probably at like 1, 2. I'm not gonna count those. But if there's, fuck it, count them. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. I didn't fully count that correct, but if there's 21 or 22 data points, we should just confirm. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 points per range. Then our snap is occurring at 41, 2, 3, the 43rd point. So at the 43rd point, we would want, let's just subtract something here. The 43rd point, assuming that it's in milliseconds. If I were to subtract this, speed percent, time start milliseconds, 43rd. Okay, this should get it on track. Let's confirm. If that's correct, we can start to compute a little bit better because we have a case that we can look at. Okay. Running. What failed? Periodicity broken. Yeah, sweepable patterns of speed change. I mean, that's all I care about for the moment. We're dicking around here. We're breaking stuff. Let's look at this other plot. Okay. Something ain't right there. I think strictly the time calculation ain't right. You know what? Maybe this is the thing. Maybe this is the issue we really have to address. Let's go back out and take a look at where it's getting and printing that time value. Because if it is part of code concerning, I don't see, so it's right here. Time is being computed here. So I think our calculation issues are starting immediately here. Let's worry about nothing else, in fact. Yeah, that is the critical thing. Worry about literally nothing else. The OSSM isn't moving because I'm actually just running this in unit tests. So to make sure I'm speeding up development, I'm only, we've abstracted out the spline function, the class, since the beginning to be independent of the OSSM so that I can run the test patterns quickly and just like generate file dumps of CSV and then look at those plots. This is just to increase the speed of design and development. And it saves my motor a little bit. I am still promising to stream where I break the thing. That'll be in May, but not today. I don't have enough replacement parts to break my OSSM at the moment. All right, T is getting computed here. T must be linear But our evaluation of spline T, this is not actually a problem. Damn. I thought that it would be the source of the issue. It is not the source of the issue. That time is jumping. In fact, we are cool with it because the time point under the speed change, should this be continuous? This is essentially our x value, the x value that we're evaluating at. And I think it should be continuous. So we need our delta. Maybe the time offset, so speed offset is required. Speed percent offset required. We have a change in speed, which is scaling our time. We want to make sure that these two linear functions just meet up with a new slope. I think that that is relevant. This is probably a relevant issue. So we do need to know when the last speed changed, or what the difference is. So time offset. So when the speed changes, we want to capture the time offset, and we do want to capture the speed. But we want to know the last speed as well. Okay. So I have the x and the speed, but the speed is just here. Do I care about the speed, or do I care about the t? Time offset. This is not strictly a subtraction. I care about the t value at that point, because what I want to do is subtract the difference between these two functions in y or in x such that they align. I still do expect that it is subtracting off about, right? Okay, so I think I just had a math issue before. Let's go back to subtracting off 43,000 milliseconds. This is as a percent of total duration times 1,000. Let's give it a go. I think I want the second function. We're going to say minus time offset. So time offset is 0 for the longest time, and then I'm going to hard code this. So subtracting off 43,000 seconds from this value, the question then becomes, is this going to force me into a state where it's, yeah, perhaps it'll mess me up a little bit, but let's just capture it. Last speed times my estimated timestamp, my previous timestamp, which is about 43,000. I believe we can still use the current one, but I just want to simplify the issue. Divided by the total duration, converting it into a percent. T is then computed, so we are just saying that we're going to subtract time offset. Now, this is back to exactly what we did before, which is a red flag, and we're going to confirm that we're insane and wrong. Let's go. The biggest change here is we've pulled this up above. We're hard coding a value based on what we believe should be the case for this evaluation. Last speed was 10%, so it should be finding the t value at this point. That is correct. Let's give it a go. Sorry, I am sure I can trust the plots, because all we're doing is evaluating our spline calculations at the moment. I Granted, um, no, I feel quite confident. In fact, we could deep dive to make sure that everything is perfect with the plot drawing. If that becomes an issue, we will do that. But the problem right now is the pure math, is just the math. As soon as we put it on device, we're going to have a whole set of new issues. But our pure math today is failing us. Now, why is T not shifted down in the way I expect? That's my question. That's my question. I was hoping to see uh, a clear step down. I do not see that. In fact, I see something worse, which is nonsense. Hmm. It's a good question, though. Are the plots doing what we want? If I remove this time offset, we still see this. I hope. Let's go. Yeah. So that was option shift 12 to open this. AI could push it a little bit, but I think that I still want to understand the logic here on this calculation. Yeah, I think this is one where if I can't stand behind it and be confident that our offsets are going to be, like, personally confident that our offsets are well computed by a human, I'm not gonna feel too comfortable just releasing this for generic patterns. Okay, cool. Things are still working as expected. The problem, yes, I think the problem is exclusively in our T calculation. So spline T is 0.5. If I just subtract, let's just confirm this. If I just pull off 0.3-ish, this is possible, right? Like, I'm not crazy. So if last speed, we're going to say time offset is equal to 0.3-ish. If the last speed changes, let's say end, this is probably the issue, and speed percent is greater than 0, because this is not actually correct yet, but we still need to make sure we have something. Then we will subtract time offset. So this is probably part of the reason why the plots were failing prior. We'll run analysis. Let's take a look at our plots, baby. Infinite recursion, plots over and over. Now, our time value did not seem to decrease at offset, which is unexpected. And then, what is happening? What occurred? Subtracting off time did not print a change. T is equal to, huh? Ah, right, same issue. And we're going to say, we're just testing here, is greater than 20%, so 0.25. Because we want to check when it's 50. So this is fine. Hmm. No change. No change. Can't, I think we should revert back to your question. Can we trust these damn plots? Are these plots doing what we expect them to do? Let's go check inside of our test code to ensure that it is simply printing the time is computed and is not forcing a time. So under awesome, test, spline patterns, main, with speed change. All right, we're gonna reset our fake clock, load the pattern. We are happy that we can load it. We are going to compute a total duration after loading. We're going to set a phase. Sure. Centimeter, okay, total. And I want to see what you are saving and exporting here. So you're getting t, position, velocity, acceleration, speed. You better just be doing it by... Yeah, no, I do not want this. I strictly want t. So this is part of the problem. We're attempting to work with t, but t is also provided by s. Ah, it's not. Interesting. Let's go compute. I thought it was. Let's go confirm it is not. Okay. So spline sample did not return this type. Let's go take a look at all the relevant places where these are initialized. Okay. So confirmed, the test was not returning or printing what I was expecting. Thank you for the tip there, Gore. Appreciate the reminder to go look for some simple things. Let's rerun with no changes to code and see what occurs. The issue is it was recomputing our time sample, which meant that I could not change things and trust that I was seeing changes. So I would like to see a bit of evidence that I now have control. To get that evidence, I am going to just, we're going to subtract 1 here. Time is a percent in this context. So we're going to, yes, fully subtract 0.5, and we should now be like halfway through the pattern. If that's the case, then I do have control back, and I can stop getting confused about false positives. I see failure. As long as the sweep passed, then we can continue. We will fix all the rest later. Okay. Here we go. Hopeful, hopeful. All right, we are back at control. We have the ability to control time. Love it. Spline T is being provided. We can set it. We can calculate things. So during a speed change, we should be able to detect, let's return to the idea of having a time offset. And we should detect when the speed percent is greater than 25. Hopefully speed percent is provided. So that is a double. Should be provided as a percent, of course. I'm going to go confirm instead of test that it's not getting multiplied by 100. That would be crazy. But sanity checks are relevant. We've learned. Okay, wonderful. Okay, so we are just going to be dumb for a moment. If speed percent is greater than 0.25, we're going to subtract off 0.3. Dumb check. Just making sure that things are doing what we expect. Okay, look. Time is still too high. Why? If speed percent is greater than this, then subtract a big old amount. Because we want this as a percent. And if I said, just confirming again, going a little crazy, if I just subtract up 0.3, here's the result I expect. Plot was lying to me a little. We're confirming now the plot is not lying to me. We're going to go through those dumb checks. All right. Yes, confirmed. Plot is still okay, or is now okay, but it is not changing time stepwise. Why? So if we're going to say if time yeah, what am I looking for? If speed percent is greater than 0.25, I'm expecting a offset here, but I'm not receiving it. I'm getting what I want. Why? I'm attempting to subtract this. It could simply be variable definition. If that is the case, then let us just do this inline. Speed percent. Okay, let's just compute. I mean, the fact that I did this statically, I mean, it could be a memory issue that I'm not thinking about right now. Because I'm just trying to do messy tests. I need a ternary. Speed percent. Greater than 0.25. Yeah, down. Let's subtract off time offset. Dumb checks. Not a code issue, just a logical issue. We're going to find out why. Did our spline pattern run? No, it did not. Okay, one more time. Yes, it did run. There we go. Okay, so that was a variable definition issue. Our logic is not wrong. There might still be remaining issues, but our logic is correct, which means that we were just fighting memory. Look at this, clean time calculation with a new slope. Exactly what we expect to see. Clean position transition, clean velocity transition. These are the plots we want. Awesome. Yeah, very happy to see this. There are remaining issues. So for instance, we can see here that for some reason we're only plotting between, not the entire pattern. What is this going to? 0.2? If this is a percent, it should go from 0 to 1. This stated, we're probably seeing that because plot duration is incorrect inside of the test. So we will I'll have to have a bit of a more clever way to count how many periods we've seen. We do that inside of the spline pattern because it knows when it's clicked through the entire time or time percent. No problem. Actually, now I'm just thinking about it. This is probably the biggest issue because total duration, it should be divided by your speed percent. Let's get to that. Total duration is divided by your current speed percent. One thing at a time. I see a new issue we're going to have to get through, but we do have now a clear time offset. We know what the problem was. The problem was memory. And so we just have to put now time offset and last speed on the spline pattern class. Let's go do that. We're going to say our private was, we'll just go with double last speed and I think long time offset. Let's revert back to our very, very simple code. Here, right? So if these are not equal, then in advance of the computation, do we have to do it in advance? Technically, since they're supposed to be equal, we could do it at the end. I think that's acceptable. That way we only have to do it once. So if speed percent is not equal to last speed percent is not equal to speed percent, and we will say that time offset, but not this one, is equal to time since starts milliseconds, and last speed percent is equal to speed percent. We want to have a computation that's a little bit more parallel to the prior. So we want to do last speed percent times the current time divided by same calculation just for now. This should cancel out except for a difference between these two speeds. But because this is static and this is changing, we cannot simplify too much more. This is only computed once at the end, therefore it will technically miss one beat, but since these are supposed to be identical overlaying functions, no one will notice. Okay, we see last percent is equal to this. What's going on? Do we have a static defined still? This might just be one of those ones. I passed the AI so I can think. Time I've said, Cannot assign to non-static data member class evaluate. What do you mean? It's a private on me. What's the issue? Last speed percent. Okay, well, let's just move it up for a moment. We'll pull it into public. Not a preference to have it in public, but that's okay. Let's go. Am I a fool? Note, member function is declared. Cannot assign to non-static data member within const member function evaluate. Yeah, okay. Defined as const. Okay, my bad. Evaluate. Thank you. Let's remove that. We want to carry information. Thanks so much. There we go. Yeah, still defined as const. One more time. Wonderful. Let's take a look at our plots. Discontinuous. But we're now more confident that it's controllable. If not, still quite annoyed. that it's discontinuous. Why? Right. Okay. So let's just now that we're confident that we have, at the very least, uh, something working, let's just set time offset to equal 0.5 and confirm what I think the issue is that last speed percent is 0. We're going to say this is there. Let's go ahead and leave my calculation, but set the gate at speed percent must be greater than or equal to 25. Because I think the issue is that last speed percent is technically 0 when we start inside of this test, and therefore it's just 0 the entire time, subtracting off the value of the entire plot, bringing it all down, and not allowing me to control the difference between these 2 points, and that it's not the case. Hey. Okay. Speed percent and speed percent. What is going on here? So we're saying essentially during a speed change. Yeah, during a speed change at this exact point, we want to compute this and subtract it in the future. It's kind of the issue. But we could do that here, could do it above, but I don't think we're going to see the change that we expect because I think this if condition is just not running. And I want to check that by on the condition, saying time offset is equal to 0.5. Make sure that it's not a value issue, but is in fact just failing. Once we're satisfied with the math, we're going to have so many exciting issues that include me destroying my motor. Okay, it is simply not hitting the if condition. That is interesting. So, interesting. Let's do this. If speed percent is greater than 0.25, which it will be, then subtract. This will help us identify the next issue, which is almost definitely just a simple memory issue. Interesting. Not hitting, not occurring. We are not changing. We're not hitting this condition. This condition is never running. Why? We evaluate speed percent in the pattern here. Speed percent. Are we plotting speed percent out of curiosity? No. Okay, we should. But we can look at the CSV, which is printing that. Let's go here into this one. Take a peek at the. I strongly dislike this extension. I would like to remove it. So I'm going to right now. Extensions, CSV, Excel. Yeah, thank you. Let's remove this. Going back up, finding our analysis here, and we want to take a look at this guy. Speed change. Yeah, okay, speed is certainly being provided as a percent between 0 and 5. Yeah, cancel, close, no problem. Yeah. Yeah, I see no issues. Why would my stepwise evaluation of speed percent to subtract 0.5 off? Oh, why would the motor get destroyed? Oh, honestly, it wouldn't. It's a pretty robust motor. I've never actually had any issues with it. When I say that, I'm exaggerating slightly. If I do something incorrect, the risk is always that I slam into the hard stop. But uh, the risk in that case is just I lose belt tension. We're not so worried about losing belt tension, so it's certainly an exaggeration to say that it's problematic. Totally fine, ultimately. All right, we're coming back here. We have got to figure out what's going on. We've got to go through bit by bit. For some reason, my stepwise, and maybe now we are going to have to ask a robot. That sucks. My stepwise evaluation of time offset never kicks in, never happens. Can I just do this? Can I just do live here, a ternary, speed percent, greater than 0.25, right? Subtract 0.5. Dude, this better work. I'm going to be mind boggled if it doesn't. Yeah, generating some warnings. But it did run through. And the other one failed. So, for some reason, unclear to me, time offset is constant. And or, so potentially like per loop inside the test, it is regenerating our pattern, which is resetting our offset, which would be crazy. It is a stateful object. Let's confirm here. Or it's intended to be a stateful object. Yeah, I mean, like, this is indicating to me exactly what we're talking about. We do know our offset is not quite 0.5, but should be closer to 0.3. Yeah, strange. Strange. Let's fix a couple things. So we're going to get into the bot. Let the bot clean some stuff up for us. So first things first, on our tests, actually just use spline sample t to determine when 3 loops have occurred. Because t must go from 0 to 1. Right. Start with that. Duration. Now, I think it is the case that if I go into the tests and it is reinitializing the pattern on every single loop causing issues, I do not see that being the case. It seems to not be the case. However, it is the case. Yeah, it is the case that somehow time offset is not getting stored. It is on the class. It is a class object. We have removed const. It is a private. Crazy. What is going on? This is a memory issue. I think it's a memory issue. Okay, let's just be dumb about it. Actually, just compute 1,000 samples. How many samples is this on screen? On screen, I believe this is 86 samples. So we're going to say 500 samples. Yeah. And I got to be more clear in specifically this test. All right. Nearly there. Nearly there. I'm excited to get out of this problem, polish it up, push it out, let people play with it. I think we're getting quite close. Once we have like this smooth pattern system working as expected, and I'll have AI look at the problem to see if we can get a little bit further, then yeah, the things that remain are polish. These will happen offline, async, and then hopefully be included in one of the next upcoming releases. And this is the plan. Okay, there we go. Let's just check to see what the current state is. We'll run our splines test. One failed, two succeeded. As long as it generated the sweep with speed change, we will continue. I believe it's just computing non-continuous. That is the issue. Not what I meant. Fools. Not what I meant at all. Okay, I meant, gosh, spaced at about to like 10 hertz. Yeah, we'll say 20 hertz. Definitely. Blah, 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 blah. All right, so the polish things that I will do will be once we get this done. I think I'll switch to polish mode, potentially jump off stream, and get things looking real pretty. Because it's got to be boring to just watch me stare at this damn thing, attempting to get it to work. Okay, now it's total climb time window of 24 millisecond, 24 seconds. It's quite long, but hey, let's give it a shot. Yep, let's run it. Okay, analysis, let's go. I'm guessing it's going to be a medium big file. Interesting. Okay, well, we do have our change. Yeah, let's increase our frequency so we only capture about 5 seconds at about 100 hertz. We do see the time stepping through as expected, but we just want less this chaos. I want fewer of these spikes. one more time, and then I'll just go back to getting things done. All right, a little bit more readable. We do have a couple of critical issues in our t calculation, but we can address those in the future. Right now, oh, it's only going to 0.1, and then it's rolling. That's crazy. That's crazy. What's going on there? Uh-huh. Right. Total duration. Yeah. Damn. Okay. I think for sure this has to be divided by very risky or risky-ish, divided by speed percent. So that, yeah, if it's 0, your time is infinite, essentially. And I'm not actually sure how it became anything other than that. Let's go take a look. We should see then that it does still continue from 0 to 1. Let's attempt to determine if that's true. Boom, boom, bum, 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 bum. Or if I'm just being a silly Billy. It goes up to 0.1. Sir, why is time going to 0.1? We need time to go to 1. Right here. This is my issue. Time should be a ramp. Computed such that it goes. I must compute in both places. Okay. I also have a math issue. I see. Divided by speed percent. All right. Back to the top. Okay. Are we now more satisfied with these plots? Let's determine the time does in fact range from 0 to, well, something. Down here at the bottom, we see negative 0.3. We'll make that assumption. And here we see approximately, I'm going to assume about 0.6. But this does seem like it's ramping from 0 to 1, and our sine, or in this case, our sawtooth is continuous. Well, not continuous, but it is the shape we expect. Okay, lovely. These are much more useful. Happy to see it. So our time offset now, we can control. Let's make sure. Speed percent does make more sense. Thank you so much. Yep. We are seeing the ternary is working. The question now is, if I subtract time offset, will it work, or are we still having a memory issue? Here, I was subtracting off 0.3 in the condition that speed percent is greater than 0.25. Great. Same condition. I'm going to subtract off 0.3. Same. No changes. If this fails, then it's because I am referencing something incorrectly. That's it. Quick check. I have a calculation error. What is up? What are you talking about, fella? Invalid operands to time offset? Oh, shoot. It's because time offset correctly is a long. Oh my God. Correctly, very correctly is a long, but for this exact test, it must be a double. So I'm guessing, yeah, damn, that's very interesting. Okay, because I'm doing it in a slightly different way. Yeah, let's take a look. This is almost certainly why things were not aligning with my expectations. Simple, simple, simple typecast. Please let me be right. And then once we see we have control again, the typecast was then failing. If control is returned, we can go back to implementing our formula, which should be simple. And all of the things you're confused about make sense again. Except the fact that my plot isn't showing. Okay, great. Wrong one, but that's all right. During the speed change, here we are. And do we see that it is subtracting off a value? Good question. Let's go back to our standard. I do not see it subtracting off a value. But I'm feeling more confident at the very least. So if speed percent is greater than 0.25, then we're going to subtract off 0.3. Uh-huh. Okay, in order to make sure that we are right in how we are wrong, we will subtract off something insane. Let's just subtract off 1,000, make it go crazy. You know what I mean? Okay, passed, run this plot. Let's crack open the speed change plot. Great. Okay, we do have control. We're in the power seat. We're driving. Now, the thing that I need to subtract. Okay, this is all coming together now. I am seeing clearly. Yes. So we have time since start, milliseconds. What we need to subtract is the difference here. Yes, this is becoming more clear. Thank you, thank you, thank you for all of your patience. We're going to just copy this function for the time being. A little non-ideal, but the thing that must change is we must use the last speed percent as our divisor. The only thing that's critical is that so if last speed percent is greater than 0 and speed percent is not equal to speed percent. So if there's a change, great. I'm now always going to permanently set this here outside of the loop. We'll clear this notion that time offset is 0. Ah, beautiful. I think we're getting it. We're getting here, folks. Last speed percent can be cleared. Good. Let's, for consistency, say delta t. Let's compute delta t as a long. Q, and here, same delta t milliseconds. Awesome. But this must use our previous speed percent as the divisor. Okay. Chill. Now this must be, because time offset here is Yeah, time since start milliseconds. I need to compute the entire time offset. So we're going to say it is time since start milliseconds. Now, careful, because what I need to determine is the jump in time. So strictly, the jump or the delta in the jump in time is this value. So we're just going to define it as a local. And is it, in fact, along? We will say so. Last time since start milliseconds. Okay. And then time offset is equal to last time since start milliseconds divided by total duration times 1,000 divided by last speed percent. Okay. LFG. We'll have to see how this handles. Well, let's just check the first case, but I'm highly optimistic and feeling confident in the origin of all of our errors. My optimism has not paid off. My optimism has not paid off. Why is this the case? I am subtracting. Well, let's take a look here at time. Time did not get computed correctly. If I set time offset to 0, what occurs? Perhaps the issue is the delta or the mod is running a little too early. Let's go peep. So this is time since start milliseconds, but we've fmodded. I don't think we want to do that yet. Because we must evaluate at just thinking this through. Mm-hmm. Mm-hmm. Okay, last speed percent. Yeah, so we're saying when a speed change is occurring, then we want to compute this. We can, again, do know that it is working. We did test that it is working. It is called correctly. The fmod might be part of the issue, but I don't think it is. So it's the time at which, with our last speed percent, which I believe is saved as a double. It is. This is the time at which we changed. Yeah, I just want to subtract the delta. What is happening? I want to actually subtract the difference between the two values. So if this is x, then I want to subtract x minus this. So that ends up being minus that. That can't be right. Current value. But I want to subtract the jump. So what I need to do is I have x. I don't want to subtract. I am probably actually just computing the wrong thing. Okay, this is making more sense. Yeah, the offset has to be equal. Ultimately equal. Okay, interesting. Ah, okay. I think I got it. Okay, I think I got it here. Let's take a last peek, last peek. Just simple math thing. I don't think I described very well what the issue was, but I will draw it out. It ended up being very easy. And again, I'm being optimistic before I see anything. Get a memory issue, distracted me, and now a math issue, but the math issue is clear, and boom. All right, here we go. Is this the kind of smoothness we expect? It is in fact smooth, to be clear, or smoothish. It is meeting where expected. It is bouncing as expected. It is failing to gracefully return down to a slower speed, but increases in speed are fine. And I now know the issue. The issue was simply that I needed to subtract off the difference in the two time steps, top to bottom. Okay, right here, actually, this is a different kind of continuity error. What I've got occurring is that I have exceeded, let me confirm. Yeah, I've exceeded 0.1. So here, I need to do another f mod between 0 and 1, and then I should be okay. F mod 1 would be fine. I think this is sufficient to allow me to do my subtractions. Let's take a look and see what occurs. We can clean up our calculus or our calculation a little bit. Something too insane. It's just about how we're computing everything. And I was overthinking it. It is clear. I just have to make sure the time calculation is linear. Lots of overthinking on this one. But here we go. Take a look. We have continuous smooth changes in speed, not jumping around and causing bad sex. This is positive. This is good. Let's also check for a speed decrease. So let's ensure that the same sort of thing works if we're going in the opposite direction. But now we're happy. So let's talk about our tests. Test spline here. We'll keep all. Keep file. Thank you. So on sweep with speed change. Here, we want to ask it to also test, dropping from 50 down to 10. And also test, dropping from 50 to 10. This can be in the same plot. With the jump from 10% to 50% occurring at 66% time or 33% time, and the drop from 50% to 10% occurring at 66% time. Let's go. We're going to pull this graph over here. I don't know if there's value in deep diving into the things that were confusing me or causing distractions, but what I will say is they're solved. I've got it figured. Let's copy, pull this guy over. So we are here. Building some clean pattern charts. Look at this. Look at that continuity during the speed change. Easy. We'll make sure that we get to see this on the actual OSSM as well. Should have a condition for what continuity means. Obviously, if I was to just compute these two values, they'd be identical. I think that's sufficient. I think the way that we could test this is that inside of the tests, we just change the speed, like inside of the unit tests, change the speed, but make sure the time is forced to be constant, using the fake clock and all that. Okay. Let's replot and see what is up. Okay. As expected, when we decrease back from 50 to 10, we are discontinuous again. So we're discontinuous on the negative. Let's just fix it. I think it's going to be as simple as an absolute somewhere here. Would it be appropriate to say that it is here? Yeah, I think it is. Let's find out. I think that is worth at least the time it would take to test. First think about, so let's try. So this is an absolute, which ensures this is a subtraction of this value and that this is a negative time. Interesting choice. Is that what we want? Let's give it a go. It's quick and free. Something broke. Semicolon. All right, where you at, plot? Okay, so the absolute in time did fail. As in, okay, first off, is this reaching 1? I don't think so. That is always a concern. It needs to start from 0 and hit 1. So we're not satisfied with that. It is looping, but not in the way that I want it to. Okay, no problem. Right, fmod. So this would become negative in what case? In the case where, well, many cases, clearly in the case where speed percent is increasing. Let's do a little bit more thinking about this. I think I want to take a peek at this boundary, though. It is touching. but that's not enough. ABS is not sufficient. We are not so ready to say that all this is going to take is a quick absolute value. So let's consider what it looks like. Let's also just do this one, where last percent is less than speed percent. So this would be the case, the first jump, which we believe is satisfactory. This is going to isolate our tests a little bit and let us see what is going on. So what I do want, yeah, is no change. No change is sufficient. No change is sufficient. Cool. All right. So on a positive change, we are still not ranging from 0 to 1. We will correct this. It needs to range from 0 to 1 in order for us to feel confident in general about what time is doing. We will deal with that. I think it's 8. We should confirm what the issue is. I think the issue is fmodding a little too quick. I don't know if I believe that's true. We'll confirm. And then when we make the change here, our value is too different. So what we need to do is, again, same thing. We compute the time value here. And then we need to subtract the difference between the two. Compute the time value at both points and just subtract the difference. There is currently a time offset, so we'll have to do like a subtraction on the subtraction. Okay, so the calculation should be the same. So I think that the difference here is that is a plus equals, which has problems of its own, could get run away pretty quick. Let's attempt. Let's see what's going on. Okay. Because that way we're constantly computing our time offset and allowing it to increase and decrease. It's its own function. Okay. Is this working? Yes. Yes, it is working. We have the remaining issue that time is not doing precisely what we want. It is not ranging between 0 and 1. It is fmodding incorrectly. Let's go check why. So here, the thing that's a little interesting. Oh, So should this be absolute? Will this cause breaking issues? If I force time to always be the absolute? Interesting question. Do I care? That's another interesting question. Okay, here is what's up. We are making sure we're fmodding here, but we should be confident without fmod that our time will cycle through correctly. The problem, though, is that it is occasionally going negative. Should we permit it to go negative? Let's remove the fmod and see what occurs. With no fmod, what is the case. Okay, taking a quick peek. Goes to 0.8 and then jumps down to negative 0.2. And okay, so problematic. This is occurring. Why? Why precisely? I didn't expect the F mod to keep it positive. We should not expect that. It should have stayed within -1 and 1. Let's ask another question. Does it matter? Does it matter if time is not between 0 and 1? Because in fact, we are using a negative time offset value. This is going to be between 0 and 1. Does this need to be? I think strictly no. I actually don't think it does need to be, especially since things are kind of working. Except for the acceleration right here. But what is happening there? Some thing. I'm not sure what. All right. We have continuity. We have some time issues, but they're not actually causing problems for us. Okay. Yeah. All right. I think I'm happy here. Let's flash this to the device and try out our pattern and look at some ramping, some speed ramping as we play with it. Okay. Yeah. First, a bathroom break. All right, let's go here. In fact, I'm gonna pop this guy over. This is the one, this is the hero. Okay, hear me? Mm. Hmm. Okay, we got progress. Things are looking good. And we'll see here. Got this. Let's see it on device. Let's see what this looks like. Mhm. Right. Cable. Where'd you go? Okay. That's item number one. Item number two. It's this guy. Quick flash this code on. Now we still are going to have some issues that we are aware of. One of these issues is just going to be having it play back smooth patterns. We know that smoothness is not delivered. Speed ramping and continuity during speed ramping, we're hoping is delivered. Okay. Oh, yeah. I forgot this guy needs big boy power. Let's go. Here it is. Mhm. Mhm. Hmm. Okay, let's have you over here, my friend. Yeah. Plant in frame. AJ in frame. Into the software repo. Let's go. PIL run. So excited for this. I hope it works. Let's get our remote. Just classic wired remote. And where are you? Cable, but no remote. Compiling. I can find it faster. All right, got it. And 3, 2, 1, plug in. There it is. All right, we're waiting. We're waiting. We're gonna get into our test. We're gonna launch. Actually, I could do the connection over here. Yeah, we'll do the remote. We just want to see visual continuity. We're not going to do a measurement just yet. The measurement is going to require the iPhone, meaning I have to switch to camera 2, which I hate, because it's just my face. But we could do actual measurement with the April tags on a slow-mo video. That could be quite fun, just to get an understanding. I think I'll do that. I think that makes sense. For now, qu'est-ce qui se passe? Connecting, uploading, writing. Good stuff. Oh, hopeful. This could be it. I mean, the data, the tests, unit tests suggest we have solved this one problem. And we just have to keep going and going. Almost there. Building up to the next thing. We should include stroke, of course, and depth. And we need to clear up our calculations after spline.evaluate is called. These are the calculations that convert it from percent space or 0 to 1 space into, okay, perfect. Here we go. Yeah, into like steps and commands to go to specific stepper positions. Okay. Going down to stroke engine, clicking in, decreasing the speed. Okay, this is not us yet. That's simple pen. We're going to go down and find test pattern. This is sawtooth. Let's go to, this should be sine wave. You can see it's, perhaps you can't see it, but I can certainly see it's jittery. Let's just speed ramp. Ah, look at that. Look at this. Well, it's at 0 now. Oh, which means it's a little angry. And hey, there's some anger there too. But okay, a little jittery. I'll tell you what, it's looking workable. Looking very workable. So it's got some continuity. Ooh, got a little angry there. Not sure what that is yet. I'm going to try very high speed just to know what's going on. So this is definitely either, this is probably our post calculation. It's also likely the thing that's limiting our play range, since we instructed it to play with the entire range. But hey, it's something. Okay, let's take a look here. Now, that is not me. I did not pause it. So, could be flooding the queue as well. But I'm happy to say that we're at the next stage of testing, which is out of the code and onto the machine. Brilliant. Happy. Okay, just for the sake of getting some clearer video, let's move some stuff around. Rearrange. Baby. Oh, my bicep guy. His arm fell off. Okay. Ah, behind. Okay, but we got a little bit more balance here too. Okay, bicep bro is here. And let's get this guy. Ooh, ooh, ooh. Excuse you, sir. Let's get this guy over here. Yeah, that's fine. All right. Let's watch it in motion. It could still be annoyed at me. That is okay. Yeah, rehoming because I exited stroke engine. No problem. Okay, so what we're expecting here. So I'm gonna talk as if you have no idea because we're gonna like cut this part and then hopefully make a little clip about it. But in brief, we're working on a system where you can draw patterns on the awesome, just little spline patterns like, you know, a sawtooth or a sine wave. Let me find it and then I'll redo that. Give me a moment. But we're going to be talking to people who don't exist because we're filming for the future with the intention for a cut. So 3, 2, 1. Yeah, we're going. This one. Hello. All right, this is the quick demo of where we're at so far with the pattern drawing tool. So we want to make sure that people can draw patterns and deliver them onto the awesomes that are out in the wild. Right now we're doing a bit of a test with sine waves and sawtooth waves, just like this. These are coded onto the device right now, but in the very near future, you'll be able to draw and distribute these on dashboard.researchanddesire.com. We took a lot of time trying to make sure that this was reproducible and continuous. Right now we're looking at seek to continuous, but also during speed changes. Luckily, we do have that. This plot right here demonstrates what occurs in the code as we change the speed from 10% speed to 50% speed, and then from 50 to 10. The first plot here is time. Time should be stepping between 0 and 1, or at least have a range of the value 1. And we should make sure that no matter what we're doing, the position here, which is in values between 0 and 1, is always continuously moving. Same with the velocity and the acceleration. We have the case for all three plots that they are smooth, or at least continuous. We're just going to give you a brief demo of what this looks like now on device. It's a little choppy, but don't worry, we'll work on it. So I'm going to load up this dev firmware, and we're going to enter stroke engine. I am now just starting a pattern, any pattern, doesn't matter which. And I'm going to switch over to test pattern 2. Test pattern 2 is our sine wave. This is a sawtooth playing out from file. Here is our sine wave playing from file. Love it. Okay. Now, if I change my speed, we see continuity. We see the speed, except for some moments like that, which we have to debug. Speed changes are continuous. Oof. We used to see giant attempts to jump over and over and over as you were changing your speed, but that is no longer present. Whatever else is happening here, though, that's up next. We'll figure it out. Thanks so much. What is occurring? It's very interesting. Position is getting computed as 1 for a lot of this time. But if position is getting computed as 1, why is that the case? Because time is stepping through, but it is doing literally the thing that it's being commanded to. It's getting commanded to do something crazy. That's all. Okay. Huh. Yeah, it's getting a high velocity, like it's just maxing, which implies what precisely? Because time is changing, the time returned at least. Let's confirm the time is changing. Time is computed here. Oh, this is definitely where we gotta like hold up a second. You know what I mean? Let's take a look. Where is evaluate called? Okay, time scale. We don't care. This is now totally handled inside of the stepper function itself. Sorry, inside of the spline function itself. All we care about is the speed percent. That's it. Meaning, we don't care about spline time. This is nonsense. We don't care about time scale. It's nonsense. Position norm. I mean, bruh. You should just spit out the sample. What do you got going on here? So ESP log D, baby. I would love everything. Give it to me all. The last thing we wanted was speed percent, and I do want to see time offset actually, which means that I'm okay with making that public on our spline. Because I think our time offset is probably getting like overflowed or something, you know, like it seems crazy. Yeah. That must be the case. Okay, this is my theory, but let's go make it a public so that I can print it. I believe that is required. Now let's confirm. Perhaps I can just read it. Hmm. Get time offset. That'd be fine. Okay. Let's re-upload here because something's going wrong. And if I had to guess, I think it's time offset. Because it is technically, yeah, so it's plus equaling, and I'm doing rapid changes every single time. Every single time. So it could be anything. It should, I suppose, be limited to range. Well, I mean, it's tempting to say between 0 and 1, but it should be limited such that it's within the range of the permissible times. It should be between 0 and 1 is the set of permissible times. Okay. Yeah. We have a little bit of thinking to do on this one. Okay, let's go. Going down into stroke engine. Speed down. A little bit of speed. Let's go down into test pattern. This is sawtooth. Let's go into the sinusoid. And already, huh? What occurred? That's sawtooth. This is sine. Thank you. Already something's going on. But that's okay. Okay, let's pause. Take a look at our logs. Okay, let's go. Give them all to me. So dump these logs here in analysis logs.txt. We're going to ask the robot to plot this with the new columns. And you can just watch this dang thing go crazy over here. Cool. And this is coming together, though. Like, things are actually working, and we're happy to see it. We'll have some smoothing to do, but quite happy with this first pass of these plots. I think this right here is certainly part of the problem. I think that for some reason we're staying above or below 0 or 1. At which point, well, I think the spline computation above that, because it's discontinuous, is just undefined. I think that our calculations after we compute things are also poor. I mean, here, look at this. Position is 3. That doesn't make sense in our context, right? Yeah, this is nonsense in our context. It's like alternating violently, like it's vacillating just mildly. Why would this be the case? Yeah, because like velocity is also jumping like crazy. Why? Why? Look at this. Like between 0 and yeah, what's going on there? Wildly jumping. We have continuity. We also have crazy, crazy lack of control. What is that reason? Okay. Yeah, no worries. I think I'm okay. Let's take a look at this spline plot. He's still cleaning things up, but that's fine. Don't mind so much. Okay, we have our spline T, which absolutely is continuing to do something as speed changes, crawling higher and higher. This is related to our offset. I still don't know how concerned we are about this, to be frank. Um, mhm. Beautiful charts though, but let's see. Position is discontinuous again. Why? Why is position discontinuous? Speed percent. All right, we're seeing the speed percent changes here. Time offset value. Okay, so it is down to -2.5. So this is is it related? I mean, it seems related. Target steps, right? Because we're going to cap this. Position being discontinuous is frustrating. Spline T not being limited between 0 and 1 is frustrating. Let's see if we can find alignment between the times where it is static and something going awry. Well, first, there's a lot of stuff going crazy here. But yeah, the computed position is not right, to say the least. The position requested seems attainable. However, yeah, everything else is crazy. What happens if... what happens if I just force correct time here? This will fix the first plot. So if time is less than 0, make time equal to 1 minus the mod. Let's just do these corrections. So if time is less than 0, no, not really, but thank you. If time is greater than 1, that's also not right, thank you. Thinking through. Okay, so if time is less than 0, what I really want to do, because we are supposed to be continuous between 0 and 1, is I would love like, let's say it just shifts down to -0.2. That is essentially equivalent to 1 minus the current value in time. So we're going to say t is equal then to 1 minus t. And we want to be clear here. We want to be f mod t1. And is it plus? No. I see, because it's negative. Right. I actually think that this is, yeah, or greater than 1. And if it's negative, if it's greater than 1, then yes. Okay. Basically this trick. 1 plus the, well, negative now. Okay. This should limit our t's to be within a reasonable range. Let's just run our tests to make sure that I'm not crazy. We should still see clean continuity in time and in all the charts, to be clear. So no issues is the hope. Let's go see here. Okay. Yes, I see no issues. This seems to be reasonable, and we're going 0 to 1 continuous, 0 to 1, 0 to 1 continuous. Okay, that is good. Now the spline plot is bonkers. So we'll assume this is now corrected. Position, however, is no longer Making sense. Hmm. Let's see what changes now that we have the time caps in. I think this will make a difference. Let's see. Okay. Yeah, we're gonna find out. Ooh, let's raise my butt up. Oh baby. Yo. Ah, crack, crack. But it's going all right. Things are sort of working here. Okay, homing. Let's just watch this for a little bit. Ding. All right, down to stroke engine. Speed down. Choose a pattern. Let's go into test number 2, our sine wave. Let's capture some data. Again, a little bit messy. Gotta figure out our calculations. Just let's see if we can capture any chaos. So everything seemed a little bit better than they did before, because time is now more controlled. That's the hope. So smooth speed ramping is what we're expecting. At high speeds, we do have some different chaos, but I'm seeing things that I like for the most part, as far as smooth speed ramping goes. Yeah. Okay. I'm going to capture this. Let's take a look. And we'll let that guy run just to make sure there's no like background nonsense. Logs.txt. And let's run our plot. Ooh. Excuse me. Okay, we're in analysis already for the other one. Well, let's just run this here. This should give us the new spline plot on this chart. And we are seeing much better continuity. Yes, much better. There are very few samples being recorded for some of these higher speed areas, which is certainly resulting in that choppiness. But I'm not mad. I'm not mad. Okay, so we have like, yeah, ranging between 0.2 to 0.1. Okay, some smooth ramps, smooth ramps. Yeah, this is not bad, not bad, not bad, not bad. Okay, yeah, high speed chaos. Yeah, very high speed chaos. Okay, so the acceleration, I believe the acceleration calculation is, it's got to be incorrect, right? What? Like, that should be smooth. Well, we'll take a look. But we're seeing reality here. Speed. Sure. I'm wondering. Looks like speed percent is getting, like, we should have this as a float, but it's getting perhaps not labeled as a float. I wonder how much control we should give ourselves. Okay, let's take a look. So speed is recorded as float. It is being recorded as a percent. Hmm. Hmm. These would be stepwise jumps if we have 100 steps, like exactly 100 steps. We should check to see if we do have exactly 100 steps. It's likely. Just don't like seeing these shelves, you know? Okay, check. I'm gonna try, I'm doing my best to smoothly ramp, but I will say this, we're not like wildly throwing against the wall anymore, which is nice. Let's run dash T monitor again, and oh, let's try to smooth the ramp and smooth the ramp, and then save. Bar, 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 bar. Let's dump this into logs. Let's run it. Def, some smoothing required. Def, 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 def. Or something. Just got to improve. Okay, so I'm smoothly ramping here, and we can see some very nasty stepping on the actual speed percent input, which is going to cause some discontinuity or perhaps there's risk of discomfort, I suppose. At high speed, we do see some destructuring of the pattern. Yeah, some destructuring. We could increase the frequency that we're sending messages to stepper at that point, but I see that as somewhat of a risk. Time offset. Yeah, time offset is fluctuating for sure. The risk is that it could get run away, but it should be roughly 0. Okay. Speed not being like kind of being forced to be on these step shelves is concerning. Let's go confirm how we're reading speed. Check to see chat. Got Eagle hanging out. Welcome, welcome. Okay. And speed is set in awesome. Speed equals speed knob times BLE value or, but right here, so speed knob equals get average reading as a percent. It should be float, my friend. Why are you not float? What am I printing to? When I'm printing, I am printing settings.speed, which is a very flat value. It does not seem to be doing anything with a float. Definitely does not feel floaty. Because we're getting force speed knob, just reading average values on pin, 50 samples. This should be floaty. Not a fan of how it's getting computed. It's okay. There should be nothing to do with the encoder. So we're going to complain to the AI and let him think about it because I want to think about other things. Okay. It looks like these data speed settings.speed is getting forced to integer steps. It's not ideal. We need it to range to be afloat and range from 0 to 100 smoothly based on the value of the speed pot. Okay. I think that the issue is possibly going to be inside of this function. Issue may be here in the definition of get speed knob percent of this. By the way, this is also wildly inefficient. There's better ways. This is also pretty inefficient. I like using a circular buffer that's always running in a task, higher cost on active memory, sure. But then you just always have like a rolling average, which I like. Yeah, because essentially this is just a loop grabbing everything all at once, float in some. I mean, the cast here is probably causing part of the issue. Yeah, it kind of sucks. All right. I sort of prefer. I'm not going to tell what I prefer. I would like it to tell me in this one case, and I will force it to circular buffer if I disagree with what it's doing. It's not inefficient. I should be more clear. This isn't the best approach. It's blocking. It measures too quickly. And something, somewhere in this code, is casting settings off speed to int, I think. It could be this. This is, of course, setting speed knob, which is this one. Okay. So it could also be here or here. I think it is literally right here, dividing by 100. Could literally be that. Huh? Fix, improve. 2-1. Ooh, got the sneezes. Excuse me. Ah. But this is not so bad. Granted, too jittery. That is chaotic. But, and of course, there's no support for high speed, and the range is not complete for some reason. Let's see if we get a little agent to figure out if my range issue is from when I first started. So the stroke range, when using a spline pattern, appears to be limited to 50% of the play range. Why? I think it's because I left some code in there. I do recall being afraid of it hitting the hard stops that I did ask in the beginning for the play range to just be 50%. I just don't know where that code went. And I was moving fast. So we'll see if he can find it. That's the dream. That is the dream. Okay. Now, what else do we want to think about here? I think that I'm next most concerned about these calculations, which I don't like. I mean, position norm, target position times steps. I mean, times 0.5 is literally there, the 0.5. So let me go save on some tokens. Save a tree. Yeah, buddy. Let's kill. Stroke steps. In fact, what is this? Target position. Delete. Here we go. Velocity per second. What is up with the? Why is it 0.5? This one doesn't make sense to be 0.5 at all. So position norm times stroke steps, velocity scaled times stroke steps. Is there any reason that was 0.5? I cannot tell you. Then we clamp between 0 speed and max speed. And then we compute acceleration. Why are you doing this? Velocity scaled, sample velocity. I mean, first off, you didn't scale it at all. Thank you. Velocity norm does not need to have a negative 1 to 1 because we are not forcing that requirement. It is just required that it is within the reasonable physical limits. Is this negative or permissible to be negative? Set speed in hertz. Okay, so we have stroke per second, max speed hertz. I want to confirm. So if your velocity, I don't believe that this is speed in hertz. Let's confirm this. Also, I think we agreed it's probably not required for you to continue, sir. Wasting time. A non-blocking ADC sampler. Approach. Okay. Kilohertz maintains. That's a pretty high hertz, bro. Same background task. Exponential mean average. Keep the call site driven sampling, but make it non-blocking with a small ring buffer. Blessing MA, no extra task. I think we want 1 kilohertz is insane. Let's say background task. About, 100 hertz would be fine. On the incasts, how aggressive should the cleanup be? In the control path, yeah, we want strict float. Yeah, sure. We'll leave the MQTT states. That is okay. Let it run. Is this, so this is not scaled whatsoever for the record, but it is sampled at velocity times stroke steps, which we're defining as the absolute value of measured stroke steps. Just multiplying these two simply does not result in hertz. But thank you so much. Velocity in steps per second. Yeah, my dude, wrong. Steps per second is not hertz. I believe we should confirm what is hertz. In the context of fast Excel stepper. This is the question we have. Okay, let's set speed in hertz. Let's go find fast Excel steppers docs. .500 steps per second. Okay, it is in steps per second. Interesting. Okay, then damn, maybe it is as simple as I'm getting essentially percent per second, and if I multiply by steps, well, if the objective is units of steps per second, might be the case. Is that simply it? Buddy, go ahead, build. Let's just try this, let's just try it, see what happens. I don't trust this at the moment. I am tempted. I am tempted to try. It is just steps again. Let's just try F abs sample acceleration. I'm stroke steps. Is that crazy? Because I'm receiving essentially percent. Yeah, I think it's okay. We'll try. We'll try. Set acceleration to acceleration steps. These are getting set as ints. Move 2. Blocking false. Let's confirm the move 2 command. I would like a definition for move 2 versus move. I want to confirm. I believe 1 clears Q and 1 does not. Blocking. So move if direction is defined. Nope, or wait. What is the difference here? Wait while is running. Wait while is running. Move okay. All right. Now move versus move 2. In the case of absolute position, move is a delta, and move 2 is a absolute. Right, heard. Move 2 is the one that we want. No question about it. Set direction pin, set enable pin, set auto enable, move, set acceleration, chill, 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 chill. Is all chill. Okay. Let this guy clear. I'll take a look. Hmm. What this guy's doing is crazy. What's going on here? You just invent an analog sampler. Yeah, granted, I didn't read what you had proposed deep enough. I don't think I'm on board with this vision. Yeah, man, show me your analog sampler. Where is it? Uh-huh. Slot. Bro, you're going a little crazy. Uh-huh. And slot. Simple task. Sampler task, my bad. So a non-returning stick period. Register pin. Bro, you went crazy. Ugh. I mean, we will try it, but this seems like hard to maintain. We're gonna make it dumber. Okay, let's go. Let's do it. Let's see what's up, and we're going to reject parts of that code. Okay, here we go. We've changed a couple of things. We've changed our sampling to attempt to get closer to smooth percents. What if we can quickly set up buffer my logs to file? From CLI. I see. Log to file. But your current working directory. Okay, sure. We can attempt. Okay, we're back here. Woof. Excuse me. I'll take a break pretty soon. I'll grab some food, and if I have some more juice, I'll come back on live. But it's feeling close. I think plausibly what I'll do is once I get this more stable, I'll just polish the feature up, and we will ship. Get some folks generating some patterns, you know? But I'll make the polish in the background. We can't ship straight to production. We are adding in waterfall review processes with the QA team, so they're going to give it a shot, test some things out, and then we'll go from there. Here we go, uploading. About 3 hours and 30 minutes. Interesting. This feature is taking longer than expected, but should be quite stable by the time we have it. There we are. Let's go. Let's go down into stroke engine. Speed percent. Well. Down. Sawtooth. Ooh. Let's go slower. Just to see. So this should be our sine wave. It is not clean, to be clear. Let's go ahead and save, and then I'll zoom in for you. I'm going to see if I can save to file. Because the port is locked, no problem. Well, we'll just do this. Log to file, and let's go through some speed ramping. Hardly exceeding 25%. That was the dead stop. That's okay. This is very high speed. And your low speeds. Something's up. Okay, let's see what happened. Did I get a file? Did you work? I did log to file, but I don't think it did anything. So it claims it's under the software directory, or the internet claims that it would save the file under the software directory. Tell you what, I don't see it. Monitor filters, log to file. Okay, let's go. Let's take this. Okay, let's see. I think the problem is that it needs to succeed. I think the first pass needs to succeed to get into the next one. So let's make this happen. Device monitor, port, PID. Okay, come on. Boom. Monitor, default, in the logs folder, located in the project root, right here. Oh, hey, lovely. It's just ignored, that's all. Okay, let's drop this in here. Let's take a look in analysis. Let's run this boy. All right, spline plot, what do we got? Do I have smooth speed? That is a good question. I think it's interesting. I don't think I can say that I do. Well, it's smoother, but this stepping is strange and present. I do think it's smoother. I think the speed is smoother. I think our time ramps are good. They make sense. I think the computed position makes sense. And the computed velocity also makes sense and feels smooth. Good. Uh-huh. Our acceleration is intense, to say the least, but it's okay. We're not in love with this yet, but we'll figure it out. And we don't like the chaos that it introduced. This is, again, roughly centered around 0. Well, I mean, not 0, but like it's not so bad. Okay. Sure. So, a couple issues. Very jittery. Could be spamming. That's for sure. Could just be that. First things first, let's tell this guy. Let's take a look at our numbers. If I look directly at the logs here, and I look at speed, I am seeing decimal values. 3 in a row, completely identical during a change, seems unusual to me. I will note it, and we'll have the guy figure out what's up. I don't think it's majorly relevant to our issue. Okay. Interesting, and I wish I had captured that. Very annoying. Seems like a queue issue, like logging too many actions or too many move to commands on the queue. I think that the best way or simplest way for me to check this, well, first off, I can clean up a lot of this code now. I mean, this is fine. So I can clean up a lot of the code here. If stop, move. Sample is evaluate. Norm. velocity, F max, move to, this is the mess. So, set speed. Uh-huh. Let me say the results of this. What am I thinking? Well, I'm a little, to be frank, disappointed in what's going on right there. Did have some of these issues when we were streaming, working on position streaming. So I'm just curious to see what we choose to do there. Okay. Use latency compensation. Okay. Da. Get current position. Yeah, we do a little bit of a calculation in between. We do move to set speed in hertz. Okay. Ooh, excuse me. Hmm. So it's very jittery. Problem one. I think that we should, as I'm proposing that it's just spamming. So in order to determine if it's just spamming, tick in milliseconds, let's set it to like, double. Let's set it to quite a bit higher. Yeah, let's just try it. The question is, if we are sending way fewer messages to the stepper, does it get significantly better at low speed? It'll have to be low speed because I have just said that you're only going to check 4 times a second for new positions. A high speed here would do you no good. No good at all. Yeah, once we hit about the 4-hour mark, I'm going to pause, take a little lunch break. We'll check to see how we're doing. If I need a little bit more time to chill, I might just make the call. It's a lazy Sunday. All right, let's go. Let's go into stroke engine, reduce speed. We're going to set our pattern. Okay, way slower, buddy. Okay, what is this telling me? Tells me that my speed is too high. So I wonder if I should just compute my speed. Because I have my velocity. Definitely speed is too high. This is seeming to be the case. Hmm. Because it can get there too fast. Okay. Well, let's find out. Maybe we just keep acceleration as it is, huh? But let's see. Keeping the very, very slow speed here. Let's just change this so that I am, hey, just go in trapezoid mode. I'm going to compute my position. Because I have a good derivative. So I wonder if it's just poorly calculated. Huh. So my derivative is here. And I'm just multiplying by stroke steps. Let's just, before I do anything, let's just like divide by 5. See what's up. Do things get better? Well, it's too high in the window that it's looking at. It's basically what we're saying. We're saying my time is going to be about 50 milliseconds. So you're giving me my speed, and if I'm computing it, but I can only expect the next point, should be fine. Should essentially already be trapezoidal. Yeah, interesting. I think there's a. How's it going? Well, it's going all right, Eagle. Here's what we got. We got. Let's take a peep. We've got the same state here with smooth continuous functions. We've been looking at a bit of our data off the device because we do have it running now, like running patterns, but we have jitter. So the current thing that I'm exploring is how to ditch the jitter. I was hoping that it was because the speed was not reading as a float. That is resolved despite how this looks. It is still stepped, but that's not the jitter. The jitter is definitely our velocity calculation. So what I've switched to as an experiment and to explore this is I switched to sending. I did think actually, truthfully, it was also that I was spamming the stepper. Now I'm only messaging it at 4 hertz, which should not be spam. And I'm just exploring its behavior as I do so. At 4 hertz, we're getting, well, I'm starting to see evidence that the velocity is too high. So we're now checking with just an arbitrary variable, 5. Uh, we're just going to divide the speed by 5 and see if it does a smoother operation. I mean, yeah, let's see if it, obviously it's still jittery. And these jitters indicate to me that it got there too fast. It only has 4 commands a second. So it's hitting its destination. It's a very slow speed. It should be able to, figure itself out, but it's hitting its destination and then waiting. Yeah, crazy. Bop, 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 bop. So what is going on? This does mean that it's just a velocity calculation problem. The thing that I can zoom in so we get the same shot, but essentially it's this. So it's bop, 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 right? It's getting 4 messages a second, but the fact that it pauses means it has time to sit there and wait. So if I did a naive speed calculation, what would occur? That's the question now. I'm going to remove my divide by 5. And we're going to just naively compute. So let's say float naive velocity should be equal to essentially get current position in steps times target position, or sorry, minus target position. Target pose minus stepper get current position. Divided by, no, thank you, it's wrong. Divided by not that less time interval milliseconds. Okay, so this is velocity in milliseconds. So these are the target steps in the window provided. So if I did naive velocity, what occurs? I want to see it here, but I also want to see it in the plot. Spline control, this is the info.
Oh, I'm just plotting a bunch of stuff. I think I am. I think I'm plotting too much or like logging too much. We've got a lot of cleanup to do. Yeah, but naive velocity, and I want naive. Thank you. Let's go. Woo! Excuse me. Just a little cold. Nothing crazy. Hey, Spuppet, welcome. I'll catch you up. I'll let you know what we're up to here. I'm just gonna do a user check. Oh, lovely. We got Spuppet, we got Eagle, we got Steven. Everyone welcome. I think we're pretty early in North America, so appreciate y'all being here. All right. So we're working on awesome pattern streaming again, just keeping this alive. Here's where we're at. This is the latest and greatest. We have solved the issue where speed ramps and changes are discontinuous. So right here we have the proof. This is time, which should always range between 0 and 1 as we're evaluating it across our spline. This is our position between 0 and 1. It's a percent of your active play range. Our velocity is not bounded in that same way. It's bounded by your max, but we've, again, recalculated, so this is plausible, and this is our acceleration. What we can see here is that we did, in fact, reach C2 continuous. I mean, we defined it, and we do have continuity on speed change. I did a lot of tests live here showing that speed ramps are working too. Like if you're slowly changing the speed over time, it looks real good. Now the issue is actually the sensation is bad. So switching cameras here, just big mode. As I play this, what I'm going to do is I'm going to switch down to stroke engine, load up our pattern, and hit go. Previously, what we've been seeing is that, right, before I hit play, what we've been seeing is jitter. Now, jitter could be a few things. It could be spamming the stepper, or it could just be bad computation. I've reduced the number of messages we're sending to the stepper to 4 per second, meaning that now, if it's anything else, it's probably just bad computation. To test this, one thing I've done is I've just removed our, essentially we were just doing velocity. We're setting the velocity in hertz as this velocity value times steps, because our position is essentially this percent times steps. I thought it would be correct. It seems to be too fast. At 4 hertz, it's very clear that we reach our point and wait. So we got to fix it. We got to figure it out. I have now computed a naive velocity, which just in the time available between, we set in advance the frequency. So in that period of time, we're just going to like say the velocity is equal to the slope between these 2 points, just to see what's up. That is the current state. So let's take a look. We can make it big. Let's set our speed. And we're checking to see how many stops we get. I mean, it sure does not feel good, but potentially, oof, that's slow. If it says the speed too slow, it might stall the motor. Not the end of the world, it's just a bit annoying. All right. I mean, the naive speed is sort of working. All right, we'll capture some logs here. Let's go to log to file. Oh, just let it run for a sec. Check on chat here. All right. probably fine. Okay, I'm going to go into logs, d timestamp should be the most recent, so this one. Okay, let's log this. We might have to consistently keep asking the robot to extend what it's able to print or put on the plot. Let's do it. Plot maybe with the new column, or actually let's overlay. But overlay naive velocity and velocity, target speed. That's the statement we're using here. These are the closest equivalents. Now, if we could use the exact velocity, that is best. It does seem to be, just weird, just slightly off somehow. We'll have to do a little bit of thinking about it. It is a chance that it's just like an acceleration issue. Like if I set the acceleration right, everything else is perfect. But I'm not too sure on that one yet. Let's in fact consider, while we're waiting for things to come through here, let's consider just dropping acceleration. And I mean setting acceleration. Just thinking about things. What is the consequence of me just setting 0 or 100% and then using acceleration and velocity alone to control the motor motion? It's an interesting thing. I haven't ever tried that. I don't know ultimately how it would fail, but I feel confident that it would fail in curious ways. I'm also tempted to go back and increase the frequency now that we have the naive velocity, because perhaps with naive velocity calculation, we can be a little bit more, like discerning. That's interesting. It's probably just in a, yeah, actually, I'm not sure why it's doing that now. It must be in a pattern where its acceleration or deceleration is just much slower than expected. Okay, let's, we do know what we want to try next. Let's try it. So instead of always setting acceleration, let's just remove this. The stepper should have max accelerations set. Let's upload and reattempt. Just see how this looks. Okay, parser done. Let's see if this thing ran. Plot regenerated. Sick peep. Spline plot right here. So, yeah, the naive velocity in purple seems to lead the real velocity. And it never actually hits the same values. Well, I guess it is calculated late, that's for sure. So it is always trying to like catch up. But what I'm seeing here is a similarity in scale. And let's confirm if I were units per second. This is steps per second. It's just multiplying by steps. It implies it'd be fine. Acceleration, sure. Target speed, chaos, offset. That's fine. These things seem to be okay. Like this seems to be stable, despite the fact that it looks absolutely chaotic. Seems to be all right. Okay, let's go. Let's see what happens when I remove just the acceleration setting step. Okay. This is still naive, by the way. Hilariously, it also looks bad. To be expected. Of course, this is at 4 hertz, so we're just testing, does it pause at points? Can find good frequencies, it seems. All right, let's keep any, so it would maintain max acceleration. Let's not modify acceleration whatsoever. Let's just set the velocity and the position. Let acceleration sit, but let's return back to the calculated acceleration times steps, which we are controlling here. Speed in hertz. Naive, sure, we got to keep it because we have it computed below and I don't want to change the plot again. Let's go back to 50 hertz, which is 20 times a second. That is high. We could try 10. I think 50 times a second is probably reasonable, appropriate. Okay, let's go. Is stopped. Yeah, sure. We eval at our time. Acceleration, we're computing, but we're not going to use naive velocity, and we want to go velocity in steps per second here, which is then clamped. So we're going to go back to this velocity in steps per second. And let's rerun, re-upload, see what's going on. But we're getting there, for real. The fact that this is so smooth, I wish I could show you some of the crazier speed ramp ones. Did I save one? No, but they're on the stream. They're behind. Like when I smoothly scroll through speed at high frequency, it looks so cool. Granted, it's got to work. Right now, this got to feel good. I think right now it's working, but not feeling good. And that's the biggest problem I have is it just doesn't seem like it would be nice to use. So we'll see what happens. Okay, let's go. So stroke engine, speed down, ball. We'll say S pattern 2. All right, back to violent shaking, baby. Sure. I would say this is a better approximation. Okay. We've just discovered a new glitch in the matrix. If we stop the pattern, like right here, watch, it will violently or quickly jump without pausing the spline time. So time probably needs to be tracked outside. Let's note this. So somewhere up here, we're gonna say major issue. The issue. Well, jittery, both. Stopping. Also, that's annoying. Stopping at all still lets the clock run inside of the spline. That can't be the case. We have to pass in the delta. So as an argument on the function, we have to pass in the delta in time. That way, if you've paused or you're in the is stopped state, we're not worried about like going crazy. All right, about it jumping on return. Okay, so noted, we're much more jittery now that we're not controlling acceleration, which, okay, is pulling me back. It's pulling me back to thinking about this acceleration here. And perhaps what we need to do is perfect our acceleration computation. I am, yeah, I'm with you there. Okay, so instantly going from 0 to say 10%, speed jump makes a jump like that as well on mainline for more. Yeah, correct. Yeah, that is fixed here. That's what you see here on plot. This is me instantaneously jumping from 10 to 50. That is here and fixed. Oh, you mean like in production? Or do you mean like in my dev branch? Maybe I should be clear. So my dev branch for this feature, yeah, if you instantly jump, it's like it would do something like this previously. That's now fixed. During like slow ramping, like right here, is that slow ramping. I'll capture some of these so we can see those logs together. Let's go lower speed to start. And stable branch. Oh, well, we should take care of that. I'll make a note of it. Okay, let's capture this. I'm going to logs. Hello. Yeah, noted. I will write that down. I don't walk off to write that down in 2 seconds. Please let me know that I failed. Um, Logs, please. Okay, so we're stating that jumping from 0 to 10 results in a jump. Not good. Instantly going from 0% to 10% speed makes the awesome jump. Sad. Okay. Let's look at our spline plot. So these are those pretty little curves when you're smoothly ramping speed. These are time, and this is time inside of the spline. So 0 is start of spline, 1 is end of spline. This is position. These are our calculations, not our measures or measurements. Orange is our computed speed, and purple is our naive velocity. We're not using naive velocity at the moment, but it is interesting to see it. Since the velocity, if we were to just say, given where you are and where you need to be, what would you need to compute? What speed would you need to have? It is odd. Okay. This is our acceleration. Just in units. Something occurred there. Okay. Time offset. We're going to stop looking at time offset. It is probably fine. We don't like what speed is doing necessarily, but I don't think it's the most critical thing to look at. Okay, so what am I thinking next? Huh. Hmm. Hmm. Acceleration, two target pose, false. Okay. So acceleration is off at the moment. We have to confirm that we think we know what we're doing with our acceleration. I think we should confirm the value is acceleration positive. I hope it is. So acceleration could be negative, which implies part of the issue. Very simply, no. We take the absolute immediately. Okay. Set acceleration. Let's confirm that set acceleration since both the acceleration and deceleration in steps per second squared. If the speed should ramp, I mean, new value will be used after call. Oh, new value will be used after call. Move by acceleration. Interesting. I mean, what if I could just get away with that? Move by acceleration. Very interesting. Huh. Yeah, allow reverse. I mean, my acceleration is surely not constant, but it is interesting to just control acceleration, then allow the thing to just move otherwise however it wants. Hmm. I'm getting tempted, but I do want to be careful. We do have to make sure we are controlled and reproducible. I am very tempted, but okay. We're going to, yeah, constant acceleration control mode. Okay, let's take a look. In this mode, the motor can be controlled by acceleration values with acceleration equals 0 to keep the current speed. Tempting. Yeah, like actually, really tempting. Excuse me. Okay, linear acceleration increase. What is this? From 2 standstill until a cubic speed function. Set linear acceleration. I mean, are we kidding? Right now, this is like, look at this plot. Look at this thing. This is guaranteeable on all of our splines. If we have set linear acceleration, and linear acceleration allows me to have a positive and negative, or like a start and stop. 2 from standstill. Okay, well, it says 2 from standstill, so let's be careful. Let's go into code. It accepts a parameter as parameter the number of steps where the acceleration is increased linearly from standstill up to the configured acceleration value. Okay. But that is, we're not going to be at standstill. Very interesting, though. Okay. Well, I do want to attempt something. There's a chance that we are just not, oopsie, not what I want. Apply. I'd like to apply speed acceleration before doing move 2, just to see what it changes. I want the simple calcs here, so we're doing absolute with capping for max excel, so this is a clamp and a clamp times stroke steps. Like these are, again, probably naive as well in their own right, but let's try. Yeah, linear acceleration is not going to be useful, but I mean, acceleration control mode is interesting. We'd have to put limits. Yeah, the motor can be controlled by acceleration values, yeah, with current speed. Cool, very cool. No, I'm with you. So what would the biggest considerations be? I mean, we would want, I mean, I want to see it, to be direct. I'm just going to do it because I really got to see it. I got to know. Seems so cool. I wish there was more, just a little bit more documentation on it, but I mean, I get the gist. Like, is there a mode? I don't think I actually have to enable the mode, but I'll take a look in a sec. Let's just see what happens when I do apply by. Based on the docs, it suggests that the new acceleration and speeds aren't even getting used at the right time until I do apply by. So there's a chance that this helps us smooth out a bit. And I will say it does seem to smooth a little, but there's still jitter at the start and the stop. Very interesting. It is failing to reach like points that it should have the capability to reach. Like this is max speed. What's going on there, pal? He ain't doing anything. Okay. Let's capture some data. Let's take a look. Up, up. This is max with apply. This is the only difference, so that apply is enabled. I think at low speed, probably it's the full range. I will say it does seem more smooth, except for those jumps, which are not measured, by the way. I can't. You have to keep in mind that when we say like get current position or something, it's never actually going to give us the position. It's just going to give us what the stepper thinks the position is, which does look trustworthy, if we're being frank. Okay. Let's go dump this in our logs, get a plot, just make sure that we're taking a peek what we're building. Uh-huh. And getting a directional vibe. Okay, so currently we could probably drop this purple curve going forward. The purple curve is the naive based on current position. We should see the current position. Oh, excuse me. I should confirm that we're not using the naive one. Correct, we are not. But it is still very bad. Very bad, very bad. Spline plot. So the orange is computed. Uh-huh, uh-huh. Okay, well, we don't like it. I'll say that. High speed is still probably out of the question until we do just higher frequency check. I am going to try acceleration control. Let's just do it. Okay, let's do a commit. Say working on, let's say before trying acceleration control. We got our acceleration, so worth the effort. Okay, I've just pushed to my branch. Folks can take a look if they want. Code is there. It is present. Logs are ignored. Thank you. We want to go in here and let's see everything we can about acceleration control. Let's go peep through it. Also just checking. Steps is equal to acceleration velocity squared divided by acceleration. Okay. I'm just curious. Reading through a little. Constant acceleration control. I want to see relevant functions. So is move by acceleration, I think is the trick here. Can be called only for steppers in if only the speed of your stepper is of interest and that speed to be controlled by acceleration. So, I mean, that is not the case. It's not the case that we only care about speed, but it is interesting. I'm just going to read through this library really quick. What are the functions we got? Oof, very interesting. You can just directly add a queue entry. Cool. Is queue empty? Is queue running? Get position after command completed. Very cool. Seems like we could potentially control the ramp generator. That's very interesting. Pulse counter, okay, fill queue. Very, very cool library. Back to the top. Just in case I missed something here. Direction pin, get high count. I think the thing we're gonna do is we're gonna be naive about it. We're just going to set setting the speed can be done with one of the four calls. The value will only be called after one of these functions. Move by acceleration, apply speed acceleration, run. Okay, so move by acceleration and speed. Let's just set these things. I'm curious. We're probably gonna hit the hard stop. Things are probably gonna break. Accelerate towards negative maximum speed if allow reverse. Decelerate towards start if allow reverse. I just want to make sure I understand the usage. If allow reverse, run backwards. Okay. So it does check if it's positive or negative, and I'm going to permit reverse. Understood. If not, it will not run backwards. Yeah, let's go. Let's just be blind. So we're going to set speed in hertz as stated here. We're going to move by acceleration. And true. We want to allow reverse. we want to change this, in this case, to no longer be absolute. I mean, don't cast like that, but thank you. You needed a what? An integer? Okay, then you can cast. Sure. And I want to confirm set speed in hertz. I think the comment there that we saw was it is only, yeah, set speed in hertz. The docs suggested can be done. The new value will only be used after call of these functions. I need to be clear. What is this after the call? You know? All right. Let's be, I don't know, untrusting, I guess. There's a good chance we hit the hard stops. Screw it. Got PIO CD software. PIO run. So I'm not doing full acceleration control because I am still setting the speed and then doing move by acceleration and computing the acceleration. If I feel slightly more confident, I will do move by acceleration only. We'll just see what's up. I think that science, baby. Yeah, exactly. Let's see. Worst thing that happens is I just have to quickly unplug something. Let's find out. Got my hand on the wire. So I guess I can wait till it gets there at the very least. We'd have to do some safety checks just to make sure it's not exceeding the bounds. But theoretically, in a literally perfect world, there's no reason that controlling by acceleration shouldn't have approximately the same positions. Okay, let me make this big. And then let's go. See what happens. All right, stroke engine, we're in. Going to change to our sine pattern and whoa, woohoo! That was a very angry one. Oh damn! All right. uh, very interesting. Okay, let's damn. Let's set it to yeah, hard exit. Woof. I think that one's gonna need a lot of work. Huh. I wonder what it taught us though. I mean, maybe it did teach us that our acceleration is extremely far off. Let's find out. Let's see. Okay, I'm gonna plug this motor back in. We're gonna find out if it did make a unusual noise. I'm hoping that it was just it ripping the belt to shreds. That'd be fine. All right, let's try. Let's go back in. Oh yeah. Literally no tension right now. There's absolutely no tension on that belt. Okay, what's going on, man? Okay. Uh-huh. Hmm. What do we want to do? So I set acceleration. God, it was so fast. It was angry fast. Let's try again with no code changes. And I think I was the problem. I'm just gonna like, what do I think the issue was here? Let's do one code change. Let's divide by 10.
Maybe divide by 100. Let's divide by 100. I'm not confident yet. Like, I do think there's a chance that our like acceleration computation is all the way off. I see you there. Wowza. Yeah. It's soft. It's definitely fast. And that was at like 5%. It was very a little spooky, a little aggro. But I actually, just generally speaking, I do think that our stepper can go faster than the hard-coded limit. I'm going to experiment with that later, but for now, wowza. Okay, dividing by 100. We're still setting speed. We're curious. We're open-minded. Just want to see what's up. Okay. Here we go. Acceleration mode. Okay. Very slow speed. I need to be a little faster than that, pal. Just want to see. Is it graceful? Oh, it's gonna overshoot. Okay. All right. Well, why is it strictly? I didn't capture enough logs, but I'm gonna capture what I do have, and we're gonna pull this in and just see what happened. I should have log to file always enabled. I will do that actually. Okay, let's go into here. Let's investigate together. Instead of logs, I only captured 109. That's okay. Oops, I'm in the wrong thing. What is my command? I think it's Python 3 // analysis / plot spline .py logs.txt. I think that's our code. Sorry. // what? Oh, // analysis. Okay, quick look. Speed was like 15%. I wonder if yeah, for some reason it just wasn't setting the negative, perhaps? Or maybe because I was doing set speed. Let's do one more trial where I don't do set speed at all. And perhaps we can make the assumption that it will completely manage speed by itself. Should we make that assumption? Not without reading. Let's go check. So just run forward. Cool. Run back. Get speed ticks. Huh? It's not really, yeah, it's not really, it's just like set acceleration. I mean, that's it. It doesn't set speed at all. It just sets accel and will blindly accelerate beyond whatever max speed. I mean, whatever speed you hope would be the max. So the request is that you're setting acceleration fast enough for it to be responsive. I think that's what I'm hearing. Set speed and ticks is called right here. Under what conditions? Sorry, what's this branch? Acceleration is greater than 0. If set acceleration is less than 0. So this is the case where if acceleration is 0, heard.
But in all other cases where it's greater than or less than, then nothing. We just set acceleration, no speed control. So it is important for us to actually set the speed, which we do, but we should, again, even at 100, it was pretty fucking fast, a little too fast. Oof, crazy. All right, well, I mean, this here is just a set of commands, and so we're only trusting the acceleration call here, multiplying this by the measured stroke in steps, and going for the best. Huh. Huh, huh, huh. It is not decelerating. Let's try one more thing. We're going to be, again, a little crazy. We're just going to remove set speed in hertz. Totally got it. Move by acceleration is it, only it, nothing else. We are going to assume that our units are correct with a factor of 100, obviously, put underneath. I would say, I want to confirm that we are speed scaling this. That should be the case right here. We see our speed scaling. What's interesting is, right, our acceleration is high at the start. Okay, this makes sense. I'm with you. I'm concerned about now, like the frequency, like how low the frequency is at which we're hitting this, because it's just so damn fast that I don't feel like we're responsive enough. So I'm going to increase to, what is this now? Like 100 hertz? So every 10 milliseconds. I'm kind of tempted to just say like, fuck it, one, go as fast as you can. So shit, let's just try it. Let's just see what's going on. I don't know the consequences of that yet. I know that move 2 would be jittery and terrible. We're going to find out what's going on here when we do this. And we are doing no set speed. What I should do then is set the max speed right now. So stepper. Okay. And we will apply. Millimeter per second down to steps. This should be our max speed. Okay, speed is now set. Done. Move by acceleration. Spooky. We'll do one more blind experiment before we go look at how other people are doing this, or take a break. I think we might take a break. Coming up on 5 hours. But one more, pretty please. Let's make sure. Can we always log to file? Let's just always have this. That's okay. We'd love to always log to file. Monitor filters. This is under common development. Yeah, that's fine. Log to file. And comma. Woof. All right, we'll go big cam. One more shot. And then definitely food time. Gotta be food time. Big cam. Here we go. Oof. Is that a copyright strike if I whistle that? Maybe. I think if I whistle more of it, definitely. Still haven't found copyright-free music that I could just play in the background. I'm I think I need music. To continue this at this rate, the amount that I'm making or streaming, I would need music for sure. And I do like streaming. I think it's a very fun way to just connect with y'all. Okay, here we go. We are ready for something dangerous. Uploading. And we'll check our context here before things happen. Right, the situation is we are still dividing acceleration by 100. We've set our speed to max speed, and we're hoping that by increasing the frequency of communication, so I believe we set our interval to 1, meaning that we're only going to wait 1 millisecond, which is not really the amount of time we'll wait, but we'll wait the minimum amount of time before running the loop again. Ah, hey. Okay, that just tells me not enough tension, and we keep losing tension because someone keeps slamming into the hard stop. That's not my fault. Okay. I mean, that's all you get for now until I. Oh, maybe I can get more. All right. Yeah, okay. Hopefully, you have enough tension. Let's go. Rehome here. All right. Rebooting, rehoming. Oh, I'll sit up. Ready for chaos. All right. Whoa. Down into stroke engine. Changing the pattern. We are on our sinusoidal wave with just acceleration. I'm gonna very slow speed. Please slow down. What? Oh, let me stop it too. What is why no slow down, sir? Why no slow down? Okay. It's a different log format. Hopefully we can parse it without changes. We will change it if we need to. All right. Some long tail logs there. Interesting. Oh, oh, I understand. The first, wait, do I understand? These got to just be errors. All right, let's take a look here. I mean, I guess it did literally exactly what it was told to do, which is just accelerate. I didn't, hmm. Yeah, it didn't get long enough in time to get a different direction because I gave it too little speed. Just nervous, you know? All right. I think acceleration only control is a risk. I think that it could be something I work on, but it's risky enough. Yeah, it's risky enough that I might not continue to work on it. Although it is interesting. Can understand why it's not used for position control. Definitely makes sense. Huh. I could add in position measurements so it has more clear feedback on where it is. I think, though, that is going to have diminishing returns. I'm definitely getting uh, the sensation that, or like the evidence that our acceleration is too high, though. Because if by acceleration alone we're still hitting hard stop, then part of the reason probably we're blasting through or like jittering all the time is probably related to the fact that acceleration is too high. We're going to do one more attempt here. I can do infinite one more attempts, but I do need to eat. I will do this actual one more attempt where I just divide by 1,000. I mean, let's just see, right? If evidence is suggesting my acceleration is too high because I cannot do acceleration-based control, then perhaps the thing that I need is just smaller acceleration. Maybe it's just that simple. And I got to figure out, like, measure or calculate the scaling factor required to get acceleration control to work and then bring it back into position control and we'll have perfection. That'd be lovely. We'll see. Okay. So loaded up. Let's go big cam. Let you watch the chaos. And I just saw a message from you. Give me a sec. Coming over. I mean, we'll still try a little bit. We'll try a couple more times. I'm not totally done with it. Oh, did I unplug it? Yeah, yeah. Of course I fucking unplugged it. Of course, this thing's a runaway train right now. Okay. Oopsie. Tension. So funny. Like I'm maxed out on the tension on my screw at the back. The only thing after this is like actually well, that's not even a problem. I can just bend now. Get a little quick fix in here. Let's give it 10 seconds. Okay. Let's go. Hey, what's going on there? Oh, I see what's going on. Wait a second. Do I see what's going on? I have no tension. No tension. Here's the thing. She pushed in all the way so much. Clear. Right, so here.
Okay. Tension exists now, but still not perfect. I probably should. I also see some other issues, some other build issues that I should work on. So there's a gentle tuning in my future, but let's go. Mm-hmm. Okay, it is big mode. Perf. We have tension. We can hit things. Love it. All right, let's go down. Stroke engine, no speed. Spline pattern. We're at like 1,000th. So if we don't see a reversal, something's wrong in config. Like, bro, you should go negative. Why didn't you go negative? Okay. What is going on here as well? I got a log that appears over and over. Task watchdog triggered. Okay. So I'm probably just being too aggressive. As the set acceleration is getting crashed. Thing is, I was just nervous. Let's go with interval. Let's go back to 50. So 20 times a second. Bump, bump, bump. Re-upload. I mean, almost definitely, we do want to be controlling the speed as well, right? So let's do that. I think before we do this, before we go pure acceleration, which I think is naive and unwise, let's make the assumption that we want to do this as well, and that we're also going to have our scaling factor for safety of divide by, I think 1,000 is insane. I think it's more appropriate to say divide by 100 in this context, but we're going to say 1,000 and 1,000 because we've seen chaos. So, I forgot to clear this one. Okay, great. This is going to be casting to int. That's fine. Honestly, it's what we're already doing. So, round 2. Let's see. Let's see what's happening. We're doing a big ol' safety. We have the set speed in place. We have move by in place. We have velocity steps. I believe all of these numbers and everything we're setting up is correct. We'll just find out. Let's find out what's going on. Is this motor's off? Yeah, it is. Okay, we'll go big mode. And hit. And hit. Thank you, sir. Let's go. Let's do stroke engine, no speed, setter pattern. No longer going to make the watchdog angry. And we are, I mean, an extremely low speed. So let's try to increase it a little. I'm divided by 1,000 after all. Okay. Okay, well, now I'm just being controlled by fear. Let's not even think about it. Let's go divide by 100. I mean, it's barely even moving. Let's divide by 10 now that we also have speed and we're not crashing our process. Let's trust the system a little bit more. And hey, if it crashes, right? Or if I can join chat on this one so you see me there. No, not without logging in. That's okay. right, this will be our last experiment, and then I gotta get some food. 5-hour stream. Good block. Good long block. Hopeful. Hmm. Okay, here we go. Down to stroke engine. Speed down. Change our pattern. Sinusoid, baby. All right. Oh, reverse. You better reverse. Oh, okay, I just zeroed it because I didn't trust it. It did not reverse, but it did imply that it was going to reverse, right? I think you all saw that too. Let's go take a look. It suggests that allow reverse. Move by acceleration can be called if, okay. Maximum speed in both directions can be set by set speed in US. I think it's microseconds. Before, I mean, I'm hoping that set speed in hertz is also fine, but we will check. And it certainly is just not going backwards. That's the thing we're seeing. Allow reverse. Oh, you fool. Yeah, false. Huh? Wait a second. Wait a second. So if acceleration is less than 0, set it to the positive and run backward. I understand. And direction pin is not undefined. The acceleration. I think apply else apply speed acceleration and stop move. Well, it's not going backwards. We'll say that. Let me confirm. I think we did capture enough. We should have captured a period where it did go back. We can just check in the logs. Let's plot these logs into analysis, into logs, nuke. And yeah, let's go. There we go. Hey, no spline control data found. What are you talking about, guy? Well, let's correct it. Let's get the boss involved. Here. These two. Fix for new log style. Okay. Not moving backwards. So this is if direction pin is not undefined, then run backwards. If it is undefined, do this. Here's the thing. I don't know if we're using, I should confirm. Where's our direction pin? Are we doing that? Do we have a direction pin set up? Let's go find where we init the stepper. Okay, where is stepper defined? Services stepper, thank you. So I was open, but I'm just gonna click through. Okay, we're gonna go into services, stepper, init stepper, connected to pin with a direction pin. Okay, we do have a direction pin enabled. Awesome. Motor enable pin. Cool. Chill. Auto enable. Okay. And direction pin. Change delay microseconds. The bool is high counts up. I mean, I've been told often that we've got it backwards, and it's probably as simple as just changing this, but let's deal with that later. Today, this with allow reverse should be sufficient. Run backwards should work. It does not work. Why? Acceleration should come back negative when appropriate. Oh, we got a log. Let's check. Go to analysis and spline plot. Let's peek. I mean, the acceleration was obviously negative when it started moving, and then it did pause, and it did go positive, and then it did go negative, and then it did go positive. Like the acceleration did change. We just didn't change direction. That's interesting. Move by acceleration did not change direction, which means we can't even give it a fair shake. Did the direction pin just get ignored? Velocity. I wonder if is the velocity getting absolute valued? Yes, it is. Ay, we're clamping. It's me. It's always me. Ay. All right. Okay, we can try one last time. We got a major bug fixed, at least. Right, because we were clamping between 0 and max acceleration. So the hope now is when I do PIO run, let me unplug this motor so I can move it. At the very least, now we should give the thing a fair shake. The concept is cool. And if it can work with position safety checks, okay. The truth is we do care a little bit more about our speed than our position, except for the safety checks. And what I mean by that is that speed being smooth is a better sensation. Like a physical, like it's better sex is the statement. To have smooth speed than choppy speed. If it also means that we could have fewer move to commands with fewer like linear ramps, I mean, I just feel like this is, it's compelling. It's very compelling. We'll try. All right, into stroke engine. Let's go full screen here. Pretty cam. Changing pattern. Here it is. And let's give you some speed. Ooh, bro. Hey, instantly. What are you doing? All right, well, let's hope for the best. All right. That's just me like pushing it to a random location. But it is, I mean, it's sort of working. Don't try speed. We're dividing by 100 right now. Play range is limited. I'm not like blown away. I am setting a max speed. So I'm probably part of the problem here.
Uh, because, correct me, acceleration is proportional to velocity squared. So my speed is probably way too low. I am wrong about that. Let's find out. First, let's take a breather. This is pure acceleration control. It's not blind to its position, but it doesn't care about its hard stops. It's definitely not getting commanded to go to a specific location either. It doesn't care about that in the least. Let's take a look at what our profile looks like. Let's grab from logs. Let's do copy path and up. Okay. By the way, every red line is a speed change. It's interesting to watch the time offset grow and shrink over time, but not critical today. Okay, so the accelerations are, oh shit, don't scare me. Wow, all right, unplugged. Um, Probably too low of a frequency again. We should get a position error readout in this. Okay. A lot of thoughts. Very interesting. Yeah, very interesting. Setting the speed definitely is very, setting speed very high results in a lot of noise. Definitely not fast enough. So we should increase that. Probably 100 hertz is too little. I mean, I don't even think we're going to hit 100 hertz, but whatever we're doing is too little. Okay. Lots of thoughts. But I think it's time for food. I think it is the best call. Curious. I would have thought that we'd be able to do better than this, you know? Like I thought I was calling it frequently enough that we get several points within each of these paths. We are getting some points, sure, but it's still not quite what I was hoping for. And definitely the velocity response, like position response data is disappointing. But like, look at this. I'm getting like 5 samples. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's 8. It's 8 samples. I guess I'm just used to this. Hmm. Lots of thoughts. I think we're going to take a breather, take a break, do a little reading on smooth step control. Take a look at what Frey D is up to. But yeah, now we've tried fast Excel steppers, constant acceleration, and gave it a fair shake. I think that there is some potential with risk of, making sure we got the hard stops in place. And well, obviously we care more about position control than this generally allows. I am interested though. So, quick summary. We're end of video. People always jump to start and end a video. So I'll recap some of the things that we're well aware of already, like folks in chat are well aware of. We have solved the issue of continuity during the speed ramp. So if you slowly or quickly change your speed, we used to jump randomly throughout the current pattern you were playing. That is resolved. You will now continuously move within the same time signature. Time always will scroll from 0 to 1, and we make sure that we are not jumping about in that pattern. We overcomplicated it. Took a little too much time on this one, but hey, it ended up being real easy. Just make sure your 2 linear functions are connected. Done. Nothing else. It means we are carrying a time offset to allow for continuous ramping, but we've seen that be relatively stable. I'll do some math to prove that it's not ever going to fly away before we launch it. I will also say we are having some problems right now with smooth control, and we're disappointed with the effects of just setting the position, target position, the velocity, and the acceleration, and then doing a move to. That has been disappointing. So we're going to continue exploring. We did one brief exploration on fast accel steppers, constant acceleration control mode, and it was tempting, but I think it assumes that we have a higher frequency back and forth with our motor than we actually do. That is all for now. It has been a wonderful 5 hours and 11 minutes with everybody. And I think that we're going to get to the phase, I've mentioned this last time as well, where we start doing offline work on this to polish it. And I'll just come in on stream to give you the updates. We won't start a new feature on stream for the OSSM until this is launched. So anytime I come on stream for OSSM, you should expect that I am doing this. But we are also running streams right now to polish the Chaster integration for the Chastity lockbox. Yeah, hope to see you in either one of those streams. And thank you so much. Have a good day.